Okay. So the subject name is business mathematics. In this, you have 5 units. Okay. Totally, you have 5 chapters. Now, the first chapter is talking about number system, the basic numbers that we are going to deal with. Okay. Every day we deal with numbers. At least a minimum of addition, subtraction, we would be learning, right? So, or we would be using. Now that there are calculators everywhere, so we would be using much of calculators all the time. But still there are much of basics which you're supposed to remember. Fine. So that is why this number system is a very, very easy chapter. Okay. So we are going to start with number system and then we will proceed further. Now in number system, you have the basic types of numbers. Now we would have only seen, as a whole, we would have seen the numbers, that's all. But in that number system also, we have certain types of numbers. And I'm sure everybody would have at least done in your high school HCF and LCM. If you don't remember, no problem. We are going to revise that and do more problems on HCF and LCM. Okay, highest common factor and least common multiple. Okay, so that will be taken care of. Next, so that will be your first chapter, number system. You can expect at least 2 marks and 6 marks questions. So as in when I do the problems, okay, I shall let you know what sort of questions or how much is the marks that may be allotted to the particular chapter and which are the important chapter for you to concentrate. Now, like PUC, you will not have complete blueprint. Okay, in PUC, you would get a blueprint from the PU board saying these are the number of marks allotted. But the same thing does not happen with Bangalore University. So it is, I am going to, go through the question papers, analyze that, and I shall let you know what may be the marks that may be allotted to each chapter. Okay. The major thing, before I continue the syllabus, you're supposed to maintain a 200 pages notebook. Ruled, unruled is up to you. Whichever you're comfortable with, you can go with the book. Okay. Please maintain the notes properly. Why maintenance of notes is important? Because every weekly basis, the notes may be asked for correction. Now, how do I correct on an online class? I have already asked you to download an app called Adobe Scan. If you have not downloaded, kindly download that scanner app. Okay, I will send you a small video where it will help you to know the usage of it. How do you use that? Okay, that I will share later, not now, later. So you will know what sort or how do you use that app, and you send me the notes for correction. Okay, so every week you're supposed to send me the notes, whatever in that week we have done, that all that notes are supposed to be reach me by Saturday through the scan app. Okay, I hope that is clear to everybody. Any doubts until here? Okay, that's nice. There's no doubts. Let's continue. So that was our first chapter, number system. Now going on to the next chapter, that is equation. Now in equations, let's see what all will happen. Now in equations, we have meaning of equations, types of equations. Okay, so we are going to first see a little theory, a very little bit of theory about what equation means and what are the types of equations. See, this subject is so nice that you will have a little application of this in your third semester, that is next year, when it comes to financial management. So mathematics, this basic mathematics will be applied in finance, in any level of finance that you study. Okay, the basic level of finance or the advanced level, you will have a little bit of mathematics being involved. Okay, they don't particularly talk about maths there, but still application will be there. So equations, what is the meaning, types, and simple problems of these linear and quadratic equations. Okay, this chapter is also very nice to solve. You will just fall in love with the numbers here. Okay, that is the one nice thing about equations. They are very easy. There is particular method. Okay, it is 2 plus 2 is 4. It is 4. You cannot make it 5, right? So you will have to understand few particular methods, and then we are going to solve the problem in those methods only. Fine. So that will be your chapter 2. Okay, any doubts in chapter 2? Anything you wanted to ask? Okay, so shall we go for unit 3? Let's understand what is unit 3. Okay, so unit 3 is talking about percentages, ratios, and proportions. Particularly, this chapter is a commercial mathematics. Now, why commercial mathematics? We are slowly trying to, get commerce into here. Okay, next chapter is commercial mathematics, but there is an introduction to that commercial mathematics in this chapter. Now, what is this commercial mathematics? Okay, you would do lot of trading, business keep happening. You can see a nearby store, a provision store, or a vegetable vendor, or a bakery, or milk vendor. Anybody, any small shop that you see, they would also make some profit, right? So they are supposed to calculate percentage of profit, and in certain cases they would also use ratios and proportions. Okay, how much are we sharing? Now, ratios and proportions are widely used in your accounts, partnership accounts. You would have heard about partnership accounts. Okay, so we widely use ratios in partnership accounts. It's like inbuilt into partnership accounts. So much we use them. And proportions, you will also use them in accounts in few chapters. Here and there, 1-2 concepts you will use. And percentages are very, very important. Percentages are used in day-to-day life, and they're very simple. There are many types of percentages to calculate. There are certain theories to know. Simple problems will be given. Okay, please understand, we are not going into too much in-depth or too complicated problems. No calculus, there is no calculus involved in your syllabus. Okay, so these are simple basic concepts which will help you understand not only mathematics but also other subjects like accountancy, financial management, and others. Different types of accounts, we will be applying these things. Okay, so these are percentages, ratios, and proportions. These are basically used to divide anything between the people. Okay, you have 10 apples with you. How do you share it among 3 people? How do you share it among 5 people? Okay, so we are going to calculate all that in a simple problems. But then when we are applying it elsewhere, or let's say when we are applying it in accounts, we will use the account terminologies. Okay, so any doubts until unit 3? Did you all understand until here? No doubts. That's great. Nice. Now, let's go to the next chapter, that is commercial mathematics. Now, in commercial mathematics, it is purely involving, or let's say 100% involvement of trade happens. No, you would have known what is trade. Okay, just exchange of goods and services for some amount of money is called as trade. So here we are using that trade concept in the mathematics. Okay, so we are going to understand how to give discount, how to take discount, how to calculate interest. You would have heard about fixed deposit. Okay, now for fixed deposit, what type of interest will bank give? You will take a loan, what sort of interest will you pay for the loan? Okay, now in that again you have different types of calculation. If you're paying EMI, everybody knows about EMI, right? So if you're paying EMI for 1 year, what is the interest rate? For 3 years, for 5 years, for 8 years, 10 years, like that we are going to calculate the different types of interest calculations. Okay, you will mainly have simple interest and compound interest. Okay, so the simple interest and compound interest is the first part, and then you have a separate concept called annuity. Now in this annuity you will have many types of annuity, and here if you see it says only theory and there is no problems on annuity. So this annuity part is again easier for you to understand. We will solve 1, 2, 3 problems here, because for you to understand the concept of annuity, okay, just reading the annuity theory will not, you know, make you understand any of the concept. You would just have to memorize or by heart the annuity. Okay, we will hardly solve 1 or 2 problem under each type or overall annuity, so that you get well equipped with the concept. Fine. So that is your commercial mathematics. So what do we deal here? We deal with the trading part, business part completely, how to give discount, how to calculate interest, what are the types of interest, for which concept which interest is being calculated, all that we will be dealing in commercial mathematics. A very interesting chapter to deal with. Okay, there are different concepts, and problems are not too big. Okay, they're somewhere for your 5 to 6 marks you can expect these problems. Okay, so that is your chapter 4. Any doubts here? Okay, someone raised the hand. Any doubts, Lakshmi? Great, nobody has doubts. Now let's go for the last chapter. Just a second before that. Yeah, and there is someone called Mr. Bean in the class. Kindly change your name. If not, you will be removed out from the class. Now let's go to the next chapter and the last chapter. Okay, so the last chapter is talking about matrices and determinants. Now in matrices and determinants, you will have this matrices is a separate concept. So we will be learning what are matrices, where do we use matrices, and simple calculation of matrices. Okay, algebra of matrices means it's a very simple calculation of matrices. So what is going to happen with matrices is we'll just learn what is you know, the addition of matrix, the subtractions of matrices, and square of matrix, then inverse of matrix. Okay, and there is this Kramer's rule. Okay, so this Kramer's rule is very important in matrices. So we're going to learn about the Kramer's rule in matrices also. Okay, this is another the overall syllabus I can say is very simple for you, just that you're supposed to practice. The more you practice, the more you will be familiar with the concepts throughout. So everyday homework, you just have to solve more sums, whatever is given in the class. That will help you to you know, gain more comfortness with the subject. Fine. So that is your syllabus of business mathematics. Okay, any doubt, any part you want me to repeat again or anything? No. This is your number theory. Now going on further, first we will understand what are the types of numbers that we have. So the types of numbers, starting with natural numbers. Now natural numbers are every other number that you have seen, okay, starting with 1 2 3 4 until infinity. No matter how many ever numbers you have, all those numbers are called natural numbers. Okay, now how do we represent this natural number? Okay, how do we represent this? Sorry, how do we represent this natural number? We represent it by saying n is equal to, see, natural numbers n. Okay, n is equal to, you have a flower bracket. Okay, flower bracket, and then 1 2 3 4 and so on. Okay, first you will have a flower bracket. You open a flower bracket and then you write the counting numbers. It may be any numbers until 100, 1000, lakhs, crores, million, billion, anything you can write. Okay, so this is the representation of natural numbers. So what are natural numbers? Counting numbers like 1 2 3 4 5. Here you are not having any restrictions on numbers, or you have not put any rules on numbers. Okay, you start from 1 and then it goes on, and they are called as, now these natural numbers are also called as positive integers. Okay, now we will understand what is integers after a while, but these natural numbers, know that these natural numbers are called positive integers, and then it is represented by n is equal to, open the flower bracket and then add any counting numbers, and at last close the flower bracket. Okay, so this is your natural numbers. Any doubts in the natural numbers? Did you all understand? Okay, so let us go further for the next, whole numbers. Now whole numbers, after knowing what are natural numbers, let's understand what are whole numbers. Now whole numbers are natural numbers which starts from 0. Okay, in natural numbers you did not have 0, it started from 1, but in whole numbers it starts from 0 and then you add up all the natural numbers. Okay, so it is as easy as this. Now you see here you have a 0. Okay, you have a 0, and then from here it starts with natural numbers. Okay. So a whole number has all the natural numbers together with 0. Okay. Now how do they represent this? Representation happens similarly like natural numbers. For natural numbers, what did they say? N is equal to flower bracket. Inside the flower bracket, they were giving 1, 2, 3, 4 and then so on. For whole numbers, we represent it by W. Okay, whole numbers, the first letter here. Okay, W is equal to 0 and then natural numbers 1, 2, 3, 4, 5, 6, and it goes on. Okay, so this is whole numbers. So let's just revise. First two, natural numbers are counting numbers which starts from 1 and then it goes on until any number that you want, and it is denoted by n. Okay, n is equal to, and then we write the numbers. Now coming to whole numbers, it starts from 0 and then it has all the natural numbers. So it starts from 0 and then we have all the natural numbers 1, 2, 3, 4, 5 and then so on. Okay, it doesn't end there, it goes on, and it is denoted by W. Okay, so these are the first two definitions. Any doubts in these definitions? Okay, so let's go on to the third definition. The third definition is integers. Okay, so the third definition is integers. Now integers, let's read them first. Okay, so let's read what are integers. The set of all positive integers, negative integers together with 0 is called a set of integers. Okay, now let's go back to the first definition. Natural numbers started from, you'll have to say me the answer. Started from when? From which number? Natural number starts from 1. Correct. Natural number starts from 1 and it is denoted by which letter? Which letter do we use to denote natural number? N. Very good. Okay, so capital N. Okay, do not use small n. It is capital N which they use always. Then coming to whole numbers, from which number does the whole number start? 0. Good. And what is the denotion? How do we denote whole numbers? Again, capital W. Okay, don't use small letters here, use capital letters. Fine. Now coming to integers. Very nice to see all of them replying. Please keep that up. Okay, now coming to integers, here what happens is you will be adding up positive numbers as well as negative numbers. Now you would have learnt you have -1, -2 numbers also in the number system, right? So 0 will be the center number or the main number. Now apart from 0, on to the right side of 0 you have positive numbers, on to the left side of 0 you have negative numbers. Okay, so integers means it includes 0 and it also includes positive integers, that is +1, all these are plus, and then it also includes negative integers. So negative integers are -1, -2, -3. Now here you will have to be careful while writing example. 0 and then it starts from 1 on either side. Yeah, sure, I will repeat. Okay, it starts from 1 on either side. Okay, on to the right side it is +1, on to the left side it is -1. Okay, and then you have 2. Here it is +2 and here it is -2. Okay, and then you have +3 and to the left side you have -3, and then you have 4 and then -4. So integer is a set of, set means it's a group. Okay, it's a group of positive integers. Positive integers means you have positive numbers and you also have a negative numbers. Okay, that's why it's called positive integers and negative integers. Okay, so all of them will come together with a 0. Now you have positive numbers, you have negative numbers, and also you have a 0. So this together, okay, this complete set here is called integer. Fine. So this complete set of positive numbers as well as negative numbers along with a 0 is called as integers. An important thing is integers is denoted by the alphabet Z. Okay, Z is equal to, and then we write the integer set within the flower bracket. Okay, I hope that was clear to everybody. Anybody has doubt with integers? Everybody understood? Okay, that's nice. So before we go into the next type of numbers, let's revise this whole slide once again. Okay, now what are natural numbers? You can always type in the chat box. What are natural numbers? Natural numbers starts from 1 and they are counting numbers. Okay, counting numbers is important. Okay, starting with 1 and counting numbers. Now, how are natural numbers denoted? Okay, they are denoted by using capital N. Good. Now, next, whole numbers. What are whole numbers? Whole numbers starts from 0. Yeah, correct. Starts from 0, but after that you have all natural numbers. So it starts from 0 and then you have natural numbers. Good. Now, how is whole numbers denoted? W. Capital W is the denotion for whole numbers. Nice. Then coming to integers. Now, what are integers? What are integers? Okay, all positive and negative numbers along with 0. Very good. So it's a set of, see, you can derive a small formula for yourself here. You have positive integers. Okay, or let's take for example, yeah, 1 second. So you have positive integers, and then along with positive integers, you have negative integers, and then you have 0. Okay, positive integers, negative integers, 0. All these are together called as integers. And how it is denoted? Capital Z. Great, very good. So that means I can assume that everybody has understood these 3 types of natural numbers or these 3 types of numbers. Nice. So let us go to the next type of number. Now, the next type of number is odd and even integers. Now here in the integers definition, we saw positive and negative. Now I hope everybody knows what is odd and even numbers. Okay, so odd numbers are those numbers which starts from 1 and then they have a difference of 2 between them. So 1 and then you don't have a 2, then there's 3 and then you have, oh sorry, it's a difference of 1 between each of the numbers. So these are odd numbers. We start from 1 and 2 is not considered. And again you have 3, 4 is not considered, 5, 6 is not considered, 7, 8 is not there, again 9. So this will become your odd numbers, which are also called as odd integers. I'm repeating it again. The odd integers are the numbers which starts from 1 and then there is a difference of 1 in between. So if you see here, you start with 1, 2 is not considered, then you have 3 and then again 4 is not considered and then you take 5 and then 6 is not considered and then you take 7, 8 is not considered and then you take 9 and so on. Okay, there's a difference of 1 always. Okay, I hope that is clear with the odd integers. Any doubts in the odd integers here? Fine. Now going on to the even integers. These are the even numbers which starts from 0. Now here is where the students make a little mistake with the confusions. So please understand, odd starts from 1, even starts from 0. Okay, even starts from 0. So even numbers starts from 0 and then you don't consider 1 and then you have 2 and then 4, 6, 8, 10 and so on. Okay, now here odd numbers, it starts from 1, and even number starts from 0. Okay, so odd integers and even integers. Now why are they called integers? What is the definition of integer? Integer includes both negative as well as positive numbers, right? So here these 1, 3, 5, 7 and 9. Okay, let me erase these values here for your understanding. Okay, so these 1, 3, 5, 7, 9, these numbers are odd numbers. Now you can equally have the negative integers for these odd numbers also. Okay, similarly for the even integers also you can have the negative even integers. Now if you see here, -2, -4, -6, these are negative even integers. But the same thing here, if you have -1, -3, -5, -7, they are negative odd integers. Okay, let's revise this slide once again. Now we understood what are integers. Integers are a set of positive integers, negative integers along with 0. Right? Now coming to the odd and even integers. Odd integers starts from 1 and then it goes on with one difference in between. So 1 and then 3, 5, 7 and so on. Okay, so that is odd integers. Now in these integers, since they include both positive and negative numbers, you are supposed to consider both positive and negative numbers. And even integers starts from 0 and it goes on. Okay, so again here positive and negative integers. Okay, I hope that is clear to everybody. Okay, so natural numbers are counting numbers which starts with 1. Okay, and then they are positive integers. Usually natural numbers don't involve negative integers. Okay, so coming to whole numbers, they are natural numbers but along with 0. 0 is included along with the natural numbers, so those are called as whole numbers. Now whole numbers are denoted by W and natural numbers are denoted by N. Okay, next coming to integers, they are a set of all positive integers and negative integers along with 0, which means you have 0 and then you have positive number and you have negative number. Okay, so both all of 3 of them will be considered in integers and it is denoted by Z. Okay, it's not denoted by I, because if you see the first 2, it was the first letter of the words that were given, but now it is denoted by Z. Okay, so that is integers. Next, odd integers and even integers. Now odd integers are nothing but the odd numbers in your number system, and even integers are even numbers in your number system. Okay, so that is going to be your odd and even integers. Okay, am I audible to everybody? And you can also see the screen, right? Great. Okay, so let us continue after odd and even integers. But if you see here, this one point you have to understand, 0 is neither positive nor negative. Okay, so 0 you cannot say it as a positive number or a negative number. It is neutral. Okay, so 0 is neither positive nor negative. So that we also assume that it is neither even nor odd. Okay, so 0 is not a even number, neither it is an odd number. Okay, you can include them in sometimes they will include that in even numbers. Sometimes it is included in odd numbers also. Okay, so that is why it is assumed that it is neither even nor odd. Okay, now coming to prime numbers. Now we already know what is an integer. Okay, so the integer is a collection of positive as well as negative numbers along with 0. Now, what are prime numbers? An integer, okay, an integer where p prime, right? So p is greater than 1 is said to be a prime number if it has no other divisors except 1 and itself. So what are prime numbers? Prime number is a number such that when you divide that number, it will only get divisible by 1 or by the number itself. Okay, so let us understand it by example. Now if you see here, you have 2. 2 can only be divisible by 2 or 1, right? So 2 1s are 2, 1 2s are 2. Either it is by 2 or it is by 1. So that is why we consider 2 as a prime number. Okay, so 2 into 1 or 1 into 2. Now like this, let's see some more numbers. Now 3 you can multiply it with 1 or you can multiply with 3 itself, right? 3 1s are 1 3s are. Do you have any other possibility of finding out divisors for 3? There is no other number which will be divisible. Okay, same thing happens with 5. 5 1s are 1 5s are. Okay, but if you take 6 1s are, and then you have 2 3s are, 1 6s are. Apart from 1 and the number itself, you have one more division or one more number where you can divide it, right? So if you divide 6 by 2, you get 3. So this is not 1 or 6 by itself. Are you able to understand? Are you able to relate to prime numbers? Are you guys understanding? Kindly reply in the chat box. Okay, moving on further, you have 7. 7 also is divided by the number or it is divisible by 1. 7 1s are 7, 1 7s are 7. Okay, likewise you have n numbers. There are so many numbers which are called prime. Okay, it starts with 2 and then it goes on. Okay, it has to be greater than 1. See, if you see the condition here, okay, the prime number is an integer which has to be greater than 1. Okay, so to remember the greater than and lesser than sign, if the opening is like this, or if you keep your right hand in the shape of a V, then it is a greater than sign. And if the same thing, if you use your left hand and show the shape, it is less than. So that is an easy way for you to remember greater than and less than sign. Okay, so the number, prime number, should be greater than 1 and it should not have any other number as divisors except 1 and the number itself. Okay, so that is prime number. Then coming to few important points you have to understand in prime number, that is 2 is the only even prime number. So if you see this example list here, you can see 2 except 2, rest all the numbers are odd numbers. 3 5 7, 9 is not used here because 9 is not a prime number. Then 11 13. Okay, then you can, I think you can take 17. 17 is also a prime number. Okay, so and the list goes on. So but 2 is the only even prime number, and prime numbers are infinite. Infinite means it goes on, the how much ever number system we have, until that it just goes on. Okay, so there are many numbers in prime numbers. Okay, I hope everybody understood prime numbers. Anybody has doubt in prime numbers? Nice, everybody understood. Now let's go for the next type of number, that is composite number. Okay, now what is composite number? Let's understand. An integer which is not a prime number is called composite number. Now if you see prime number, I told it has to be divisible by 1 or the number itself, right? Now apart from prime numbers, the other numbers are called composite numbers. Okay, so an integer which is not a prime number. So if you see here, it's not a prime number, is called a composite number. Now, if you take 4, okay, if you take 4, what all divisibility you'll get? 2 2s are 4. Then you have 4 1 4s are 4, and you have 4 1s are 4. Right? So, and if you take 6, I already gave you an example here. 6 1s are 6, 2 3s are 6, 1 6 are 6. Same thing for 8. 4 2s are, 2 4s are, 1 8s are, 8 1s are. So you have so many options for 8, right? So an integer which is not a prime number is a composite number, and few examples are 4, 6, 8, 9. Now 9, let us see 9. Now 9 is 3 3s are 9. Then you have 9 1s are and 1 9s are. Okay, we'll do one more number, 12. Let's take 12. Now if you take 12, 3 4s are, 4 3s are, 6 2s are 12. Okay, 6 2s are 12. This is also there. And then 12 1s are and 1 12s are. So if you see 12 and all, you have 1, 2, 3, 4, 5 divisors. Okay, you have many options here to arrive at 12. Correct? So such numbers where you have more divisors, those are called the composite numbers. Okay, so I hope everybody understood composite numbers. Any doubts in the definition part? Do you have any doubts? Okay, now let us understand few points about composite numbers. A composite number n has the divisor other than +1 and +n. Okay, so this point you will understand when we start with the problems. Okay, you will have a lot of options like this, right? So the divisors 2 into 2, 4 into 1, they're talking about that. When we start HCF and LCM, you'll be able to understand this number of divisors. Okay, and the last note is, okay, and the last note, 0 and 1 are neither prime nor composite. Okay, now if you see here in prime numbers, they say P is greater than 1, right? So P is greater than 1, and in a composite number, it says it is not a prime number. So this 0, the number 0 and 1, both are neither prime, they are not included in prime, nor they are included in composite numbers. Okay, so 0 and 1 are kept separate. They are not prime. What are natural numbers? They are counting numbers starting with 1. Good. Now how do we denote natural numbers? Okay, natural numbers are denoted by capital N. Good. Then going on to whole numbers. What are whole numbers? Yeah, whole numbers are all natural numbers including 0. Okay, they are not said as counting numbers with 0. They're usually told as natural numbers along with 0. Okay, it starts from 0, and how they are denoted? How are whole numbers denoted? Capital W. Good. Then coming to integers. What are integers? What are integers? I also give you a kind of formula. Yes, set of all positive and negative numbers along with 0. Correct, along with 0. So 0 is also there, negative and positive together with 0. Good. And how do we denote integers? Good, capital Z. Okay, we use capital Z to denote integers. Now, odd and even integers, if we have odd numbers in the series, then it is odd integers. If we have even numbers, then it is even integers, both positive and negative together. And 0 is neither positive nor negative. You cannot put that under completely positive only or negative only. So that is why what we do is, it is neither even nor odd. We just keep it neutral, saying it is not positive nor it is negative. Okay, so that is until odd and even integers. Now going on further, we understood prime numbers. Now what is a prime number? Who can answer this quickly? Type it in the chat box. What is a prime number? Exactly. So prime number is a number which is divisible by 1 and itself. Okay, it is usually said which is divisible by 1 and itself. So example, the easy example is 2. So 2, it is divisible by 2. So 2 by 2 is 1. And again 2 by 1 is 2. So it's something like 2 ones are 2 and 1 twos are 2. Okay, only those two are the divisors which you can get. So you can only divide 2 by 2. Okay, so you can only divide 2 by 2, which is 1, and then 2 by 1, which is 2. So if you see the number which can be divided by itself, so 2 is divided by 2 and which is divided by 1. Such numbers are called prime numbers. Then 2 is the only even prime number, rest will be odd numbers. You have many other numbers being involved. And how natural numbers are infinite, which means there are so many numbers in the number system. Similarly, prime numbers also, there are too many numbers, so that is why they are called as prime numbers are infinite. Infinite is countless. Then coming to composite number, if it is not a prime number, it is called a composite number. Okay, now here we took, yes, which is divisible by many numbers. Here we took an example of 2. So 2 is divisible by 2 or 1. Okay, but composite number, if you take 4, 4 is divisible by 2, and again it is divisible by same number, it is divisible by 1. Okay, now how to understand easily? Check the tables. Okay, 4 ones are 4, 2 twos are 4, 1 fours are 4. If you take 6, 2 threes are 6, 3 twos are 6, 6 ones are 6, and 1 6 are 6. See, you have more numbers which is getting divided. So that is composite number. Easy definition. And integer which is not a prime number. If it is not a prime number, it is called composite number. Okay, and this note is important. 0 and 1 are neither prime nor composite. Okay, 0 and 1, you cannot take it under prime also. Why 1 is not taken under prime? Because it has to be greater than 1. You cannot take 1 as prime number, it has to be greater than 1. Okay, so any doubts until here? Did you all understand? Anybody has any doubts until here? Any part you want me to explain it once again? Great, everybody understood. So let us move on. Let's go further And today we will be understanding rational or rational numbers. Okay, however you may call it. Now, what are rational numbers? Now, rational numbers are the simplest form of P by Q. Now, if they give you a number in fraction, okay, then it is called a rational number. Okay, P by Q, P divided by Q format it has to be. That is condition number 1. And there is one more condition to this, that is where P and Q are integers. Okay, so P and Q are supposed to be integers. This is condition number 2. And there is one more condition where Q is not equal to 0. Okay, so this Q, the denominator should not be equal to 0. So this is condition number 3. So when they ask you what is rational number, few of them pronounce it as rational number. Okay, that's fine. So what's a rational number is? It is the simplest form of P by Q. That is condition number 1, where P and Q, where this numerator and denominator are integers. So why integers means both positive and negative numbers can be utilized. Okay, both it can be positive, negative, positive or negative, any combination can be considered. That is second condition. And the last condition which is compulsory to be followed is that Q is not equal to 0. This is compulsory. If Q is equal to 0, then it will not become a rational number. Okay, so how many conditions are there for rational number? How many conditions are there for rational number? 3 conditions. Now, can you say me what is the first condition? Can anybody say me what is the first condition which is given here? It has to be in the simplest form of P by Q. Okay, P by Q is the fraction form, simplest form of P by Q. Okay, and what is condition number 2? Yes, correct. It has to be in the simplest form. What is condition number 2? P and Q are integers. Okay, whatever fractions we have, they are supposed to be integers. Good, good. Then what is the last condition? Denominator Q should not be, denominator Q should not be denominator Q should not be equal to 0. Good. So denominator Q should not be equal to 0. So let's see few examples. Good, good. I've got many answers. That's good. Keep participating like this in the class so that you're more active and you'll be able to understand it quickly. Okay. So a few example, let us see. Now 4 by 7 they have given. So 4 by 7 is in the form of P by Q. See, this is P and this is Q. Okay, so first condition approved. Okay, they have followed first condition. The number is in the form of P by Q. Second condition, P and Q are integers. Now what are integers? Both positive, negative numbers along with 0, we consider them. Okay, those are called integers. So 4 is an integer, 7 is an integer. Yes or no? Both 4 and 7 are integers, right? Yes. Okay, good. So 4 and 7 are integers. Now second condition is also done. Okay, they have complied with second condition. Now coming to condition number 3. Now Q is nothing but the denominator. Now denominator, is it equal to 0? Is the denominator equal to 0 here in 4 by 7? No, they have directly given a number called as 7. It is not 4 by 0, okay, but it is 4 by 7. So it has also complied with condition number 3. So a rational number or a rational number is nothing but It has to comply 3 conditions. So the first condition is it has to be in the form of P by Q. See, 4 by 7, 3 by 5. Again, these are integers. 5 is not equal to 0 and they are P by Q format. And then if you see another one, minus 2 by 3. Minus 2 is also an integer. Okay. And then Q is not equal to 0. Okay. There's a number called 3 and it is not 0. And it is in a P by Q format. So this is a rational number. Now, rational number, how do they denote? Okay. Rational number are denoted by capital Q. Okay, so we give a capital Q. So that is a rational number. Clear? Did you all understand what are rational numbers? This is mostly asked for 2 marks. Okay, it's a 2 marks definition. Define rational number, what is rational number, or difference between rational and irrational number. Okay, I will say you an example once again. Okay, so if you have a number, let's take a different number. Let's say 2 by 3. Now 2 by 3 is in the form of P by Q. It's a fraction. P by Q is there. And then 2 is also an integer. 3 is also an integer. Okay, and then 3, that is the denominator, is not equal to 0. Okay, so that in that case we call 2 by 3 as a rational number. Okay, you want one more example? 5 by 10. Even if you simplify them, it will be 1 by 2. Even this is not a even this is a rational number because P by Q and then Q is not equal to 0. Can you all hear me? It's clear, right? So there's no problem with the voice. Okay, great. So P is not equal to, Q is not equal to 0 and P and Q are integers. Okay, any doubts in this rational numbers? Everybody understood? Okay, now let us see few more points under them. I'll just clear this slide. Okay, let's see few more points. Every integer is a rational number. Now every integer means every positive, negative number is a rational number. Okay, then 0 is a rational number since 0 by 1 is a form of P by Q where P and Q are integer and Q is not equal to 0. So this is an extra addition. Now we saw all these examples of 4 by 7, 3 by 5 and everything, right? Now there is one more example which we'll have to understand. Let's say the example is 0 by 1. Do you think this is a rational number? Do you think this is a rational number? Okay, there are few no's also. See, simple thing is always remember 3 conditions and apply all the 3 conditions. Now first, say me, is this in the form of P by Q? Good, Lakshmi. Yes, it is in the form. Okay. Is this in the form of P by Q? Yes. So 0 by 1 also is in the form of P by Q. Now that means first condition is complied. Then second condition, is 0 and 1 an integer? 0 is also an integer, right? So 0 and 1 is also an integer. So condition number 2 is also satisfied. Okay, so condition number 2 is also satisfied. Then what is condition number 3? Q is not equal to 0. Here we have 1 and not 0. Right? So condition number 3 is also satisfied. So which means since condition number 1, 2 and 3 are satisfied, so this form, that is 0 by 1, this is also called as rational number. Okay, many of them will have confusion in this. Many will get confused, students, while you're solving problems. So please be careful. Apart from other integer numbers, if at all you have 0 in the numerator, I hope everybody knows this is called as numerator and this is called as denominator. Okay, if you have 0 in the numerator, no problem. It is still a rational number. The only condition is this form 1 by 0. This is not a rational number. Okay, it is not a rational number because q is equal to 0 here. Okay, understood? Any doubts? Okay, now let's go on. So this was rational number. Now going to irrational number. Now we understood what is rational number with 3 conditions, right? Now irrational number is nothing but when those conditions are not fulfilled. Let's read this. A number which cannot be, which cannot be put in the form of p by q. So first condition is not satisfied. So then it is a irrational number. If p and q, where p and q are integers and q is equal to 0. If it is not in the form of p by q, then it is irrational. Simple. If it is in the form of p by q and p and q are integers, q is not equal to 0, this is rational number, which is denoted by capital Q. Okay. Now coming to irrational number, if there is no p by q, they will simply give you one number. Okay. But for this, if you have a square root, cube root, or if the root is for 4, such numbers, are they in the form of p by q? This number is in the form of p by q? Yes or no? No. So in such case, we call them as irrational numbers. Okay, I'll repeat it once again. If any number is not in the form of p by q, then it is called as irrational numbers. Example, easy example for you to understand. Square root of 4. What is the answer? Square root of 4. 2. Correct? This number, square root of 4, is an irrational number because this is not in the form of p by q. There's a square root and a number which is inside. Okay, so this is a form of irrational numbers. Only one condition to be fulfilled. It should not be in the form of p by q. Understood? Any doubts in irrational numbers? Any confusion between rational and irrational numbers? Okay. Good. Everybody understood. Let's move on now. So that completes your basic theory of number system. Okay, we understood what are the types of numbers and how it has been done and everything. Now we will start with the problem side, that is LCM and HCF. Okay, first we will solve LCM. I'm sure, one second. Yeah, correct, Gauri. It should not be in the form of p by q, my dear. It's not p and q. It is p by q. P by q means p divided by q. Okay, that is the form. Correct. Good. Okay, so that was your basic things. Now let's understand the the LCM part. Now LCM is the full form of LCM is least common multiple. We always have been calling them as LCM widely. It's widely used as LCM, and we'll be solving some few very, very simple problems. LCM and HCF problems can be asked for 2 marks and 6 marks. Okay, 2 marks or 6 marks. You may get problems for that. Okay, now first let's understand the definition of LCM. Now the least common multiple, do not forget the full form, least common multiple of the given set of integers is the, from here it's important, smallest integer which is divisible. Okay, you have to only consider the smallest integer which is divisible by each of the given integer. Okay, if they give you a number, you have to start from the smallest integer. Let's usually, okay, the tip is usually start, if it is divisible by 2, start from 2. Okay, that's the easiest form for you to crack down. Few numbers will not be divisible by 2, it will be divisible by 3. Okay, in that case start from 3. See the smallest integer where you can divide the number and then go on and divide the number. Whatever is left out at the end, that we will consider later. Okay, so that is least common multiple. So that's why it says least means smallest, common which is there in everything, and multiple. Okay, so that, yes, I'm repeating it once again. So the least common multiple or LCM is nothing but you have to consider the smallest integer. If a number, let's take for example 4. Now 4, by which number it is easily divisible? Which number can I take? 2. So I can say 2 2s are 4. Okay, 2 2s are 4. Correct? Now if I take 2 here, for the next 2 1s are 2. Right? Let's take another number. This is for 4. Now 4, the smallest integer I can consider is 2. But for the same thing, if I take, let's say 9. For 9, which is the smallest integer I can take? Can I take 2? 2 is not possible because 2 4s are 8. So I will take 3. So 3 is the smallest integer. 3 3s are 9. And then again I will go 3 1s are 3. Understood? So this type of finding the multiples is called prime factorization method. When I solve the problems like this, 2 and 2, and see, I take the multiples here onto the left side, and on the right side I have their factors. So this is called as prime factorization method. I usually use prime numbers. What are prime numbers? Numbers which are divisible by 1 and itself. Okay, so if you take 2, 2 is divisible by 1 and itself. 3 is divisible by 1 and by 3 itself. So I usually take, so there's no rule, okay, but I usually take prime numbers and divide the given numbers. So that's why it's called as prime factorization method. Okay, now this part, the next line is very, very important. Listen to me. Express each number as the product of primes. Okay, product of primes means, see here I have 2 and 2. Okay, so for 4 I can write it as 2 into 2. I can write it as 2 into 2. Instead of writing as 2 into 2, what I will do is product of highest power of all factors. Now this 2 into 2, I can write it as 2 square, because 2 square also means 2 into 2. Yes, I'm repeating it again. 4, the number 4, I can write it as 2 into 2. Correct? Now this 2 into 2, I can also write them as 2 square. Okay, now let us do the same thing for 9. 9, I can write it as 3 into 3. This 3 into 3, I can write it as 3 square also. Yes. So 3 square also is there. So everybody understood until here. So that is product of primes. Then what is LCM? LCM is equal to product of highest power of all factors. Okay, it's the highest power of all factors. Now we will understand this with one simple example, and then we will get back to the other problems. Okay, so we'll solve one very simple problem for you to understand. Just give me a minute. Yeah, Manas, I'll repeat it. Before that, we'll solve the problem. Okay, by solving problem, you'll understand LCM much better. Okay, I'll stop the share. 1 second. So find the LCM of 12, 21 and 24. Now, how can I write 12 under factorization method? Okay, I take 12. Now, which is the least number I can start with? Can I start with 2? I can say 2 6 are 12. Correct? 2 6 are 12. So that is my first number. So 2 6 are 12. Now, my next number will become 6. So how can I write 6? Again from 2. 2 3s are 6. Okay. Again, now my number will become 3. Now 3 is a prime number. I only have to divide by itself. So that is 3 1s are 3. Okay, so 12, I started with 12 and I divided it by 2. So 2 6 are 12. Then after this step, now my number is 6. So 2 3s are 6. Now again, for the last step, my number is 3. Here, what will happen? It's 3 is a prime number. So I have to divide by itself. So 3 1s are 3. Now, how can I write 12? 12 is equal to 2 into 2 into 3. Can I write them like that? 2 into 2 into 3? Yes or no? Yes, I can write them as 2 into 2 into 3. Now, I will modify this 2 into 2 into 3 a little more. How do I do that? 2 into 2, I will write them as 2 square and into 3. So 3 is only one number. So I will give that a power of 1. So 3 to the power 1 is 3 only. Okay. So 2 into 2 is 2 square and 3 is the single number which we have. So this 12 can be written as 2 square into 3 to the power of 1. Okay. So did you all understand the how to find the factorization of 12? Everybody understood for 12. Good. Now, let us solve for 21. Okay, now let us solve for 21. This PPT or PDF will be sent in the group, so you can copy down and solve the problem. Do not worry. Okay, so let's do for 21. Now, 21. Which is the smallest number I can use for 21? I cannot use 2 because 2 ones are 2 and then 1 will be remaining. So I'll go with 3. 3. So 3 sevens are 21. 3 into 7 is 21. Now, next my number will become 7. So 7 is a prime number. So since 7 is a prime number, I have to divide that by itself. 7 ones are. Is there any option to divide 7 other than 7 and 1? 1 sevens are 7, 7 ones are 7. Those are the only options that we have. So 21, for 21, what are the factorization? 3 into 7. Since both the numbers are repeated only once, I can just say 3 to the power 1, 7 to the power 1. Okay, did you all understand the factorization for 21? Any doubts in that? Okay. Now we'll go for the next number, that is 24. Okay. So for 24, now 24, it is divisible by 2 for sure. Okay. So we'll start with the smallest integer, that is 2. So 2 ones are 2, 2 twos are 4. Okay. Which is nothing but 12 into 2 is 24. Did you understand this? 2 ones are 2, 2 twos are 4. Then now my number is 12. Again 12 I can divide it by 2. 2 6 are 12. Good, good. Come on, say me the factors like that. Okay. 2 6 are 12. Now next my number is 6. Now how do I factorize 6? Again 2 threes are, not 3 twos are, 2 threes are. Okay, because 2 will come here. Okay, 2 threes are 6. Then last, now 3 is my number. So 3 ones are 3. Now how can I write the factors for 24? 2 into 2 into 2 into 3. Now instead of writing 2 into 2 into 2, I can say them as 2 cube. Okay, we just factorized the numbers 12, 21 and 24. Okay, and today we will continue from there. Okay, just a second. Yeah, so let us start. So can you all say me how do you factorize 12? Okay, so first we have 12. Now which is the number should I start with? 2. Okay, so 2 6 are 12. And again my next factorization will be 2. 2 3s are 6. Okay, now 3 is a prime number, so I cannot take any other number, so I have to go with 3 ones are 3. Okay, so that is the first factorization. Now going on to the next number, which is 21. Okay, in 21, from which number can I start? 2 or 3? 3. Okay, so 3 sevens are good. Okay, 3 sevens are. Now 7 is a prime number again, so where I will not be able to actually multiply or I actually divide by any other number except 7 and 1. Good, so 7 ones are 7. Then the last number 24. Now in 24, from which I can start? 2 or 3? 2. Now if I start from 2, which is 2 ones are 2, 2 twos are 4. Then going on further, what is the next number again I can take? Again I'll have to go with 2. So 2 6 are 12. Okay, now again 2 3s are 6, and since 3 is a prime number, 3 ones are 3. Okay, I hope everybody is clear until here. Any doubts? No, great. Now let's continue. After this, how do we find LCM? Now for 12, okay, for 12, I have factors which says 2 into 2 into 3, right? Now for this factor, I can write this as 2 to the power 2 into 3 to the power 1. I can do this, right? 2 to the power 2 and 3 to the power 1. So that is for 12. Now going on further for 21. Now for 21, I can write it as 3 to the power 1 into 7 to the power 1, because there is only 1 which is available. So 3 to the power 1 and 7 to the power 1. Next, Coming to 24, I'll write it here. Okay. Now 24, how many times is 2 repeated? How many times is 2 repeated? 3 times. So 2 to the power 3 into 3 to the power 1. Okay. 2 to the power 3 into 3 to the power 1. Okay. So let's rewrite this again for your better understanding. I'll just erase this first few part of it. Okay. So you have 12, which is 2 to the power 2 into 3 to the power 1. 21, which is 3 to the power 1 and 7 to the power 1. And then again you have 24, which is 2 to the power 3 into 3 to the power 1. Okay, so everybody is clear until here how to write all this. Now, next step, out of the factors that we have, which is the least number? Out of the factors that we have, which is the least number? 2. Now, 2 is the least number. So we are supposed to calculate LCM. So in that, 2 is the least number. Correct. Now, for 2, now if you see 2, we have 2 with 12 and also with 24. Now, out of these both 2's, which has the highest power? Highest power means you have 2 to the power of 2 and 2 to the power of 3. Right? Oh, that which is along with 24. Correct. So 2 to the power of 3 is supposed to be considered. Then the next least factor after 2, which is the least factor? 3. So 3, and 3 has to the power 1 everywhere. So I will just take 3 to the power 1 into, and the next last number that is available is 7. Okay, so 7 to the power 1. So to calculate LCM, we start with 2, where you get to the power here, but to the power you're supposed to consider the highest power. Okay, now multiply this. 2 to the power 3 is 2 2s are 4, 4 2s are 8. So 2 to the power 3 is 8 into 3 to the power 1 and 7 to the power 1 is nothing but 3 into 7. So 7 3s are or 3 7s are 21. Now can you calculate and say me 8 into 21? 168. So the LCM of 12, 21 and 24 is nothing but 168. I hope that is clear to everybody. Anybody has doubts until here? Okay, good. Now let's go to next problem. Next problem is I think I gave this as homework. It's okay. If you have, many of them sent me the answers which were right. Very good. But now let's try and solve this problem. Okay. Now, first number is 36. Okay. Now first number 36. From where can I start? Should I start with 2 or should I start with 3? 2 into 18. Yeah, you can start with 3 also. Okay, then also you would get the answer. If you start with 2, 2 ones are 2, there is 1 remaining, and then you have 18. Now again, 2 and 18, how much do you get? 18 by 2 is 2 9s are correct. So 9 2s are or 2 9s are 18. So the next one again you can go by 2, which is 9. And then next will be 3. 3 3s are 9 and 3 1s are 3. Now this is one part. Now 36 is also divisible by 3. Let us do with 3 ones. Okay. So same 36 number, we will start with 3. Let's see if you can get 3. 3 ones are 3, 3 twos are 6. Yes. Then 2 6 are 12. Then 2 3s are 6. Then 3 ones are 3. Now, if you see both of these numbers, just a second. Now, if you see both of these factorization which we have done, if you start from 2 also, you get 2 power 2 into 3 power 2. Even if you start with 3 also, you get 3 2 times and 2 2 times. Again, you get 3 power 2 into 2 power 2. Which means you start from 3 or you start from 2, it's okay. In such numbers, both the places you get the same answer. Okay, I hope that was clear. I'm going to just erase one of it because we are getting the same answer. Okay, so let us continue. Now that was for 36. Now going on to 40. Now 40, from which number should I start? I can go with 2. So 2 20. 2 20s are. 2 2s are 4 and 0 will be brought down. Next. Again I can take 2. 2 10s are 20. So 10. Next. Again I can take 2. 2 5s are. 2 5s are 10. Then again 5 is a prime number. I cannot have any other number. So 5 ones are 5. Okay. Now the next number 48. Now 48, I'll start with 2 again. That is the easiest number for me to solve. So 2 2s are 4, 2 4s are 8. Then 2 1s are 2, 2 2s are 4. Then for this, I can go with 2 6 are 12. Then 2 3s are 6. So now 3 is a prime number. 3 1s are 3. Good, good. Everybody is replying. Keep replying like that. Now, let us see the factors. So here you had 2 into 2. So here you had 2 into 2, 2 times and 3 2 times. Now for the next 40, what is the factor? How many times 2 is repeated? How many times 2 is repeated? Check properly. For 40, how many times 2 is repeated? 3 times. So 2 to the power 3 into 5 is repeated only once. So 5 to the power 1. Then for 48, how many times 2 is repeated? 2 to the power 4 into 3 to the power 1. Correct? Now let us calculate LCM. Now LCM is equal to, the least number that we have is 2. So I'll write 2. Now for that 2, which is the highest power? We have 2 to the power 2, 2 to the power 3 and 2 to the power 4. So I take the highest power. So 2 to the power 4 into, which is the next least number or the next number? 3. Now 3, we have 3 to the power 2 and 3 to the power 1. So I am supposed to take the highest power. So 3 to the power 2 into, which is the number left out? 5. So 5 to the power 1. Okay. Now can you say me what is 2 to the power 4? 16. Good. 2 2s are 4, 4 2s are 8, 8 2s are 16. Then 3 to the power 2. 3 into 3. 3 3s are 9. Into 5 to the power 1 is 5. Now multiply all of that. 16 into 9 into 5. How much do you get? 720. So the LCM of 36, 40 and 48 is 720. Everybody had got the right answer. Okay, very good. Keep trying. So, and one more thing, in examinations, any problem, this subject, any problem that you solve, the final answer always is supposed to be highlighted like this. Okay, just put a box around it, because in examination when you keep on solving, no, there will be too many numbers, so the the evaluator will not be able to identify which is the final answer. So always highlight your final answer. Okay, any doubts in this problem, this LCM problem? Anybody has any doubts? Any part you want me to explain it again? Good. Okay, now let's go for the next problem. You guys want to try this problem? Solve it in your book. Solve it in your book. I'll give you 2 minutes. Solve it in your book. We will again discuss here. You get 2 minutes to solve. Good. I'm getting many answers. Nice that everybody is very quick. Okay. Now let's quickly solve this problem also. We'll stick to black color. I think that is more convenient. Okay. So the first number is 16. Okay. That was too much. Yeah. 16. So from which number should I start? Good. I'll start with 2. 2 8s are. Then 2 4s are. Very good. You have to say and I'm going to do. 2 2s are and then 2 1s are. Good. Then next number 24. Now 24 again I can start with 2. So 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 3s are 6, 3 1s are 3. January, check the numbers. It's not 2 1s are, my dear, it is 3 1s are. Okay, next 36. I'll start with 2 or 3. Both is applicable for 36. Okay, so let's go with 2 only. It's easy. Okay, we'll have that rule starting with the least number. Okay, then so 3 ones are 3, 3 8s are 16, because 1 will be remainder. See, 2 ones are 2, sorry, 2 ones are 2, 1 will be the remainder. So I get 16, right? So 2 8s are 16. Then 2 9s are 18. Now 9, again it will not go in 2. So I'll go with 3. 3 3s are 9. 3 1s are 3. Very good. Now let us quickly check the factors. Now for factors, first factor, it's very easy to find out the first factor. So which is 2 to the power 4. 2 to the power 4, because we have 4 2's available. Next for 24, 2 to the power 3 into 3 to the power 1, because we have 2, 2 and 2. 3 2's are available. So 2 to the power 3, and only 1 3 is available. So 3 to the power 1. Next, coming to the 36, 2 we have 2. So 2 to the power 2 into 3 to the power 2. We have 2 again. Okay, now let us find LCM. LCM is equal to, which is the least number? 2. And which is the highest power for the least number? For 2, which is the highest power available? 4. 2 to the power 4 is available. Then into 3. So for 3, the highest power available is 2. So 3 to the power 2. Okay. Now, can you say me what is 3 to the, sorry, can you say me what is 2 to the power 4? 16. Very good. And 3 to the power 2 is 9. So 16 into 9 is 144. So as and when you get your final answer, always highlight the final answer. Very good. Everybody is able to solve it. Good. Okay. Now, we will go for another problem. One more problem we will solve. Okay. This solved PDF will be sent in the group. So you need not worry. Okay. Can you try this? You'll get another 2 minutes. Just give it a try. Again, I will solve this in the class. Okay, we will solve that, Padmapriya. Don't worry. 2100 we will solve. Darshan, is that the LCM value you're trying to say? 76? No, you get a very big number because you have 3 digits and 4 digits number, right? So you get quite a big number. Okay, let's solve this. No problem. Good that you've given a try. Others who are solving, just keep solving. If you have any doubt, you can surely look in here. Okay, so let us solve. Before I start the problem, students, please put your names in the participants list. Okay, I don't want any nicknames of yours, because if I find any nicknames, I'm going to remove them from the class. It's a strict warning. Kindly change it to your full names with initials if you require attendance. Okay, I'm getting few answers. 37,800. Yes, that is the right answer. Meghana, Sharath, Yashaswini. We will solve it, okay? That's not the right answer. We will solve it now. Okay, so let us start. First number, 72. Now 72, from which number can I start? I can start it from 2. Okay, let's solve it quickly. We have another 10 minutes of the class. Okay, so 2 3s are 6. So I have 1 remaining. That is 12. That will make it 12. So 2 6 are 12. Then 36, again I can start with 2. 2 1s are 2. 1 is remaining. So 16. 2 8s are 16. 2 9s are 18. 3 3s are 9. 3 1s are 3. So that is for 72. I hope everybody got it for 72 easily. Okay. Now going on further, 108. I can start with 2 again. 2. 2 54. Correct. So 2 5s are 10. 2 4s are 8. Again, now 54. Since it is ending with 4, I can again divide it by 2. So 2 2s are 4. 1 is remaining, which will make it 14. Okay. So 2 7s are 14. Good, good. You people are fast. Next, 3 9s are 27. Next, 3 3s are 9. 3 1s are 3. So this is what we have got. Now coming to 2100. We can start from 2 again. No need to worry about big numbers. We can start from 2 again. 2 1s are 2. Okay. Now the next number is 1, right? So now what we will do is, we will, instead of considering only 1, I am going to consider 2 digits here. Now when I consider 2 digits, I am supposed to add 1 extra 0 when I solve it. Okay. When I'm going to consider 2 digits here for the division, I have to add an extra 0. Okay. So that will become 2 5s are 10, and this 0 will come down as it is. I'm repeating the step again. Listen carefully. 2 1s are 2. For the second step, I am not only considering 1, but I am going to consider both the digits, that is 10. So 2 5s are 10. So since I'm considering both the digits, I'm going to add a 0 here, and then 5 and then 0. Okay, I think this is where you might have gone wrong. Okay, now to easily understand, multiply 1050 into 2. Okay, you will get back 2100. That is the that is one of the tip where you will be able to solve it directly. Okay, now let us continue. Now next, again I can go with 2. So when I'm going with 2, now at first instance, I can take 2 digits. There is no problem. So 2 5s are 10. Then again, I have 5. So 2 2s are 4. Now if I make this as 4, 1 is remaining, right? So what I'll do, 2 5s are 10 again. Did you understand this step? Guys, did you understand this step? See, this is where you will miss out a number, or you might miss out how to go about the problem. Okay, now next step, I think we cannot go with 2. Let us try with 3. Now 3 1s are 3. Now 3 1s are 3 means 2 is remaining, right? So 2 is remaining. Now how much do you have? 3 2s are sorry, 3 7s are. So we're going to start with 7. 3 7s are 21. I have 22 here. 3 1s are 3, 2 is remaining, right? So 22 is there. So what I'll do, 3 7s are 21. 1 is remaining. So this will become 15. So 3 5s are 15. So 3 into 175 will give me 525. Now coming to the next. Since we have 5 at the last, I think we can go with 5 directly. Okay. So 5 3s are 15. 5 3s are 15. How much is left out? 2, 25. So 5 5s are. So 5 5s are 25. Then 5 into 7. 5 7s are 35. And then 7 1s are 7. Okay. So did you all understand this part? Especially 2100, how to factorize? Anybody has doubt in that? These are first few problems. So we'll take it a little slow. That's not a problem, but everybody has to understand. So everybody understood. Yeah, total answer is 37,800. Correct. Okay. Now, now this page is full. We'll add another page and there we will calculate the LCM. Okay. Okay. Now here, to calculate LCM, now for first, which is the first number? 72. Okay. Now for 72, how can I write the factors? How many 2s I had? How many 2s I had? The number of 2. 3. So 2 to the power 3 into 3 to the power 2. Correct? 2 to the power 3 into 3 to the power 2. Next number, 108. How many 2s I had? 2 to the power 2 into 3 to the power 3. Okay, 2 to the power 2 into 3 to the power 3. Then 2100. So how many I have? 2 to the power 2 into, we used only 1 3, right? So 3 to the power 1 into, we also used 5. So 5 to the power 2 into, we also used 7 at the last, 7 to the power 1. Okay. Now final LCM calculation, the least number is 2. Okay. Which is the highest power for the least number? Highest power for the least number. 3. See, 2 to the power 3, 2 to the power 2 and 2 to the power 2 is there. So 3 is the highest number here. So 2 to the power 3 into, which is the next number? 3. Now for 3, which is the highest power? 3 again. So 3 to the power 3 into, which is the other number? 5. So 5 to the power 2. And we have 7 7 to the power 1. Now you're supposed to multiply all of this. You're supposed to multiply all of this, and then we will get, and then we are going to get the number directly. Okay, so the final answer everybody got is 37,800, which is the correct answer. Very good. Everybody got the correct answer. I hope this is clear. I hope this is clear to everybody. So this is LCM by prime factor method or prime factorization method. Okay. I'll try and send you few more homework questions where you can find out LCM like this. Okay. I'll share it in the group so that you can solve those problems. Fine. Great. Good. So one second. So nobody has doubt, right? You can also see the screen, right? Okay. So everybody has done the homework, the problems which I gave. Okay, great. Now, the answers for the homework, I'll send you in the group. You can cross verify, you can check with the answers. If you have any doubt, you can get back to me. Okay, so I could, like that we can do. Now let's move on. Let's go on to the next concept under LCM. Okay, this is still under LCM only, and this is called as division method. Now, we have two methods in LCM. The first method is called as prime factorization method, where we solve each and every problem. Okay, so where we solve each and every problem there, and we will be then finding out the LCM. Okay, now in division method, let's see what are the steps that we are supposed to use to solve the problem. Okay, so the first step which is given here is steps to solve the problem. Write all the given integers in a row. So instead of solving each one of them separately, so we are going to write every number in a row, and then we are going to do the prime factorization. Okay, the only difference between the prime factorization method and this method is that here we will be writing all the numbers together, and we will be choosing this the number, the suitable number which can divide all of the integers or all of the numbers given to us. Okay, so what is the first rule? We'll have to write all the numbers in one row. Okay, whatever numbers is given in one row. Then second one, divide, sorry, okay, that is by. Okay, divide by a suitable, this is not buy, this is by by. Okay, divide by a suitable prime number which exactly divides two of the given integers. Here they're just only talking about two, but you may have many more of it. Okay, so divide by a proper integer that is suitable for all the numbers. Then write the quotient and the undivided numbers obtained in the next row. Now suppose if you take for example, let us understand with an example only, that will be easy for you. Now suppose if we have one second. Okay, suppose if we have let's say 4 and 15. Okay, 4 and 15 are two numbers given to us. Now we are supposed to find the LCM of this. So which is the first number I can pick? I can go with 2. 2 2s are 4, but 15 I cannot actually divide 15 by 2, I get some point. Okay, so what I do, I write down 15 as it is. Then I'll take 3. Okay, I'll take 3. 3 5s are 15. 2 I cannot do anything, so 2 will remain as it is. Okay, next again I'm gonna just go with 2 1s are, and 5 will remain. Again 5 1s are. Okay, if at all you're not able to find any particular number, then we can just go by the number and carry it down so that we can solve it later. Okay, so this is how we are going to do with the division method. Now, step number 4. Repeat the procedure described in step 1 and 2 till we get a row of numbers which are prime to each other. So until we get prime numbers. Prime numbers are those which are divided by 1 and the number itself. So here if you see the number, that is prime number is 5 or 1. Or you have another prime number which we had here, 3, 2, all these are prime numbers, right? So we will stop until we get 1 at the end. And then how to find LCM? The LCM of the given integers is the product one of the divisions and the number in the last row. Okay, Bharat. You will understand that. Wait until once we start the problems, you'll be able to understand it. Okay. So how do we find LCM? It's very simple. Just multiply all the numbers from here. That is 2 into 3 into 2 into 5. And then multiply these two numbers. That is 1 into 1. Okay. So what we are talking in the third step is, if we are able to divide the number, we will divide the number by 2. Now take for example, everybody listen to the third step once again. That is very crucial. It's very important in division method. So we have two numbers 4 and 15. Okay. Now for 4, I will take 2. 2 2s are 2 2s are 4. Correct? I am able to divide 4 by 2. But I cannot do that for 15. Now 2 7s are 14 I will get, but I don't have 15, right? So what I do, I will just write down 15 below. I am not going to do anything extra. I will just write down 15 below. Okay. Now in next step, I'm going to take 3. 3 5s are 15. 3 5s are 15. Okay, now I solved 15, right? Now 2 I'm not able to do anything. So 2 I will take it down directly. From here to the next step, I will take it down directly. Okay, next step 2. Again I'll take 2 here. So 2 1s are 2. 2 1s are 2, I got the answer. Now 5 I cannot do anything. I will just take down 5 as it is. Okay. Next step 5. 5 1s are 5. Now here I already had 1. So no need of doing anything. So 5 1s are 5. Now if you take down this 1 directly, now we have the final quotient to be 1 everywhere. So this is how we do the division method. We just keep repeating this until we get 1 at the end. And how do we find LCM? We will find LCM just by multiplying all these numbers. Okay, we're going to multiply all these numbers and we are going to multiply these numbers also with them. Okay, let's go to the problem. Once we do one problem completely, you will be able to understand it better. Okay, so did you all understand this part of the steps first? Did you all understand the division method? Okay. Now let's go to the problem. Okay, this is your first problem. So the problem says, Aishu, we are solving the problem, so you will be able to understand it. Okay, do not worry. The steps, whatever we are going to use here, that is what it was given there. Okay. Yeah. So the first problem is asking us to find the LCM. Okay, it's asking us to find the LCM of 5 numbers. Okay, so what are the 5 numbers? We have 8, 12, and then 16, 24, and 36. So the first rule says that we are supposed to write them in a straight line, or we are supposed to write them in a same row. Once we write them in the same row, then we are going to go on and continue solving the problem. Okay, so let's start solving the problem, then we will see. So first we will write them in a same row. 8. Now instead of having too much of spaces, or instead of putting commas in between like in the question, what we will do is we are going to leave some space after each number. Okay, so 8, then we'll leave some space, 12, 16, 24, 36. Okay, like this. So first rule is we are supposed to write them in a single row. Now just see the numbers. Do you think all the numbers are divisible by 2? Do you think all the numbers are divisible by 2? See, I can divide all the number by 2. Okay, now one after the other, say me the numbers. I'll start with 2 here. Okay, now 2 4s are 8, so I can take 4 here. 2 4s are 8, correct? Then for 12, 2 6 are 12, so I'll write 6. 2 6 are 12, right? Next, for 16, 2 8s are 16, 2 8s are 16. Next, for 24, 2 1s are 2, 2 2s are 4. Okay, so, and the last one, 36, 2 1s are 2, there is 1 remainder, so 16. Okay, so 2 8s are 16, correct? Okay, I'll repeat this step again. Okay, for those who have not understood, please listen carefully. So here, I'm taking 2 as the prime number. Lakshmi, please wait. The answer is not 1872. It's much lesser number. Okay, we'll just check. So we are starting from prime number 2. Now let us divide each of them by 2. So see, I'm saying division because 8 by 2 is, you'll get a answer, that is 4, right? So instead of that, we are using tables. Tables is much easier for you while solving HCF and LCM. So 2 4s are 8, 2 4s are 8, 2 6s are 12, then 2 9s are, sorry, 2 8s are 16, then 2 1s are 2, 2 2s are 4. Here 2 1s are 2, 1 remainder, so this will become 16. Okay, it will not become 7, but it will become 16. So 2 8s are 16. So this is your first step. Now again, which number can I take? Almost everything is divisible by 2. So 2 again. 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 6s are 12, 2 9s are 18. Correct? Did you all understand this step? Everybody understood this step? Okay. Now, next step. Now here, this step, I will again take 2. Let us divide all that numbers which are available for us with 2. Okay. So 2 ones are 2. Done. 3, I cannot do anything. Leave it. We will see later. 2 twos are 4. I can go with 2 twos are 4. Then 2 threes are 6. This is also done. 9, I cannot do anything with 9. Okay. So I leave it there. Now, which are the numbers which we have left? Which are the numbers which we have left? We only divided 2 ones are 2, 2 twos are 4 and 2 threes are 6. 3 and 9 are left. Now what I will do, I will just take down the 3 and 9 as it is. I am not gonna multiply, divide, do anything with that. I'll just take it down as it is. Okay. Now next, we will go by next. Now if you see next, we have lots of numbers which are divisible by 3. Okay, so I will take 3. Now here 1 already is there, so leave out 1. I can go with 3 ones are 3. Yes, 3 ones are 3 can be done. Then again 2, I cannot do anything, leave it. 3 ones are 3, that is done. Then 3 threes are 9. Yes, 3 threes are 9 can be divided. Now, which are the left out numbers? 1 and 2. I cannot do anything with them, so I'm just carrying it down. I'm just bringing it down as it is. That's all. Yeah, Rajalakshmi, the answer is correct. Please wait. Let's finish. Okay. Now, going back to the next step. Now, which are the numbers left over for us to do? 2, right? So, there is only 1, 2. So, 2 ones are 2. And I cannot do anything with other numbers. So, I just take it down. 1, 1, 1 and 3. And lastly, I can go with 3. 3 ones are 3. Everything is brought down. Okay. So this is how we factorize when we have numbers. If you don't get a actual value, or if you're not able to get the value there, we are gonna just bring it down as it is. Any doubts in this calculation? Okay. Now let us find out LCM quickly. Now it is very easy to find LCM here. Okay. Now how do we find LCM? Just blindly multiply all of these numbers. That is 2, 2, 2, 2, 3, 2, 3. Just blindly multiply all of these numbers. That is when we get the LCM. Okay. So LCM is equal to 2 into 2 into 2 into 3 into 3 into 2. Okay. Now, if you see how many 2's do we have? 1, 2, 3, 4. Correct? So, 2 to the power 4 into how many 3's do we have? 1 and 2. 3 to the power 2. I'm repeating this again. I think few people had this doubt. How do we find LCM? Just count the number of 2's that we have used. 1, 2, 3, 4 2's we have used. 2 to the power 4 into 3 to the power 2. And apart from that, we had 1's. That's all. 1 into 1 into 1, 1 into everywhere it was 1. Let's go back to the problem. If you see the last line, we had 1's only directly. Okay. So we can just multiply 1 once if you require. If not, the value remains same. Now, can you say me what is the value of 2 to the power 4? 2 2's are 4, 4 2's are 8, 8 2's are 16. So 16 into 3 3's are 9 into 1. So 16 nines are 144. Very good. Many of them gave the correct answer, and always the final answer is supposed to be inside the box. Okay, you have to write them inside a box. So did you all understand the problem? Anybody has doubt? Okay. So we will solve one more problem. Yeah, let's solve one more problem. So here the numbers are 6, 7, 8, 9 and 12. Okay, so these are the numbers given to us. Now in these numbers, what is the first rule that we are going to apply? How should we write them first? How are we supposed to write them? Keep answering. Good. Write everything in a same row. Let us do that quickly. So we write everything in a same row. 6, 7, 8, 9, 12. Now I can start with 2, right? So I'll start with 2. It's always better to start with 2 or 3, whichever is okay. Okay, don't go for the higher numbers. Now if you see here, we're starting with 2. So what will be the first number? What will be the first number? 2 3s are 6. I cannot do anything with 7. So I'll get down 7 directly. 2 4s are 8. Then 9, can I do anything? I cannot do anything. So I'm just going to get it down. Yeah. Students who are giving me answers, very good. Please just wait for a while because there are others who are trying to learn and solve. Okay. Good that you're giving the answers. Then 2 6 are 12. Okay. So this was the first one. Now if I see I have lot of 3s, I can still go with 2, but then not many numbers are there. Okay, let's go with 3. 3 1s are 3. 7, I cannot do anything. 7 is a prime number. Okay, I cannot do anything with 7. Then, so 3 and 4 also I cannot do anything. Then 3 3s are 9. 3 2s are 6. Okay, now once more 3 I will take because I have 1 3 which is available here. So 1 I cannot do anything with 3. 7 also cannot be divided by 3. So 7 as it is. 4 also cannot be divided by 3. So 4 as it is. 3 1s are 3 and 2 also will remain as it is. Now next we will take 2. 1 will remain as it is. 7 will remain as it is. 2 2s are 4. 1 remains as it is. 2 1s are 2. Okay. Now going further, I'll again take 2. 1 remains. 7 remains. 2 1s are 2. 1 and 1 will remain as it is. The last step, I have only one number which is 7. So 1 remains. 7 1s are 7. All the other 1 will remain as it is. Okay. Now, what is the LCM? Let us find out the LCM. Now LCM is equal to, just blindly multiply all these numbers. You can individually multiply. 2 3s are 6, 6 3s are, then again into 2, into 2, into 7. You can do that also. Okay. Yeah, very good. Another way of doing is count how many number of 2s are there. 1, 2, see we have 1, 2, 3. So 2 to the power 3 into 3 we have only 2, 3 to the power 2 into, we have 7, 7 to the power 1. So which will give us 2 to the power 3, 2 2s are 4, 4 2s are 8. 8 into 3 3s are 9 into 7. Okay. So 9 into 7, just a second. Let me rewrite this. It's too congested there. So I have 8 into 9 into 7. So the answer is 504. Very good. Many of them gave me the right answer. So everybody understood. Everybody is able to solve the problem. Okay, I'll just rewrite this also because I'm supposed to send you this as notes later. 2 to the power 3 into 3 to the power 2 into 7 to the power 1. Okay, we'll go to the next problem. Anybody who did not understand this? Anybody who did not understand the previous problem? Two problems that we solved? Okay, so which means everybody has understood. Fine. Now will you give it a try? Try this problem. I'll give you homework questions separately. Okay, try this problem now. Will you do it? Okay. Try. Give it a try. Let me see who can say me the answer. Good. I'm getting few answers. Very good, very good. So everybody is getting the right answer. One more minute and then we will solve the problem, okay? We'll just wait for a few more answers to come. Maximum of them have answered. Everybody is supposed to solve an answer. Okay, please give it a try. Darshan, give me the final answer. Multiplication part is fine, but give me the final number, okay? Okay, everybody has given the answer. Good, let's start. So first we are supposed to, okay, wait, let me change the color. So first we are supposed to write everything in a same line. 72, 108, sorry. Yeah, 72, 108, and then we have 2100. Okay. So first, which number should I take? 2. Okay, 2. 2 3s are 6, 1 is remainder, 2 6 are 12. Very good. Then for 108, 2 5s are 10, 2 4s are 8. Then for 2100, 2 1s are 2. Next, I cannot take anything with 1. So what I do, I take next 2 numbers. Okay, I take next 2 numbers here, that is 10. Now in that case, what will happen to my number here is, I have to add one extra 0, and then 2 5s are 10. Because if I multiply 2 into 150, I will not get 2100. Okay, so and then 0 will remain as it is. Fine, so this was the first step. Very good. Now, next, which number should I take? 2 again. 2 1s are 2. 1 is remainder. 2 8s are 16. Correct? 2 8s are 16 I get. Then 2 2s are 4. 1 remainder 14. 2 7s are 14. Next, 2 5s are 10. So that will complete 1 0. Then 5. 2 2s are 4. 1 remainder. So 2 5s are 10 once again. Okay. Now, next step. Next step, which number? You can go with 2 again. You can still go with 2 and then take 3. Okay, anything is fine. 2 9s are 18. 27, can you do something? 27, can you do something? No. Nothing can be done. 525 also we cannot do anything. So what we'll do is 27 and 525 will remain as it is. Then going on. Now we can take 3. Now 3 3s are 9. 3 9s are 27. And for 525, 3 1s are 3. So there is 2 remaining, 22. Okay, so 3 7s are 21. Sorry. 3 7s are 21. 1 is remaining, 3 5s are 15. That is how it is you are supposed to calculate, because sometimes you will not know 3 into 175 is 525. So 3 ones are 2 remainder, and then for that again 1 remainder and 50. Now we can go with 3 ones again. 3 ones are 3, 3 threes are 9. Now here 3 5s are 15. 2 is remaining, 25 is there. Can we do anything with that? Just check. 175, can I divide that by 3? No, I get some point. Okay, so I cannot do anything with this. So what we will do is we will keep 175 as it is. Don't take points in LCM calculation. Okay, now let's quickly do the last step. 3 ones are 3. And then for 175, we'll have to go with 5, I think. Okay, we'll have to take with 5. So 175 remains. Okay, now going with 5. I'll just add another page and continue there. So which are the last numbers we had? 1, 1, 175. 5. 5 threes are 5 threes are 15. Okay, like how you have division method in LCM, similarly you have division method in HCF also, but the way we solve the problem is a little different. Okay, so we will see how to solve the division method here. So first we are supposed to find out the HCF. We are supposed to find out the HCF of 210 and 55. Now this division mostly happens like a normal division. Okay, so let us start. So first step, what you're supposed to do is find out which is the greater number and which is the smaller number given. Now out of 210 and 55, can you say me which is the greater number? $210. So it's very evident. So since 210, okay, so we will write it like this. Now 210 is greater than 55. So we shall divide 210 by 55. This is the first step that you have to do. First find out which is the bigger number, which is the small number, and out of that you're supposed to, once you identify which is the bigger number and the smaller number, divide the bigger number by the smaller number. Okay, it's the basic division that we do. Now after this, next step, we are going to do a normal division. So the bigger number, that is 210, is going to come in the center and we do normal division. So we are going to do division using 55. Now how much can I divide? Like 210 by 55, do I really get the direct number? Can you all find out and say me what is the number I can use? $55? No, not 42. Don't go by 42. Okay, so that will be a very bigger number. See, even if you divide 210 by 55, you get 3.81 something. Okay, so what we will do is 55 threes are we will take. So what is 55 threes are? 55 threes is 165. So 165. Now let us subtract 210 minus 165. How much do you get? How much do you get? Others also. I want others also to reply. 210 minus 165. You get 45. So 45 is the remainder in the first step. Okay, sorry, the second step. Now what is the first step that we did? First step is we wrote this saying we will divide 210 by 55. Second step, what did we do? 55 and 210 we started dividing. 55 threes are 165, and then we got the remainder as, this is the remainder, that is 45. Okay, so clear until here? Any doubts? Let's continue then. Now the next step, okay, we are going to follow it up here only. The third step. Now 45 we have got. Now 45 we will make it as a dividend and the divisor. Now 55 will come down. Now this 55, whatever was there, this is gonna come here as 55. Okay. Issue 3.8181 I cannot take. No points cannot be taken directly. Okay, we are only gonna take whole numbers and then we are gonna do it. Okay, now here what we will do is, now I am supposed to divide 55 by 45. So I can take 45 ones are correct. You people are correct. 45 ones are 45. So what is the remainder? 10. I'll have 10 as the remainder. Okay. Now next step, I am supposed to take, or I am supposed to consider this 45 for 10. Okay, I'll make 10 the divisor and we will have 45 in this place. Just a second. We'll have 45 in this place. Okay, now I can go with 10 fours of 40. So what is the remainder? 5. Okay, so 10 fours of 40, the remainder is 5. Now I will continue it in the next page. Now we have 5, and then what was the other number which was remaining? 10 is gonna come down. So 10, so I can go with 5 twos are 10. Okay, 5 twos are 10 and the remainder is 0. So this is the last step. 5 twos are 10, the remainder is 0. So this will end our division part. Now how do we consider what is HCF? Okay, now in this last step where 0 is the remainder, we have taken 5, or we have divided 10 by 5. Correct? We have divided 10 by 5. The quotient is 2, Pavan, correct? The quotient is 2, but understand, wait for a minute. In the division method, you are supposed to take this last number which we have divided, that will become the HCF. So HCF is equal to 5. This is a little different from what we learned in factorization method. I'll repeat it again. Please listen carefully. Now, in this step, first step, we are supposed to identify which is the greater number and which is the lesser number. Now, the greater number is 210. So, we take that in the center, and the lesser number is which we divide with. So, 55 threes are 165. I get remainder as 45. And then I have 55 here. So this 55, I mean, which is that 55? This 55, which I'm going to take it from here. Okay, that 55 will come down. And now I'm going to reduce that again. So which is 45 into 1, which is 45. So I have remainder 10. Now, after getting one remainder, I will take this 45 and I'll get it here. Okay, so 45 I have. So 10 fours are 40. 5 is the remainder. We continued this in the next page because since I didn't have the place there. So 5 was there, 10. This 10 went on to the next page and is written here. Okay, so 5 2s are 10. I got 0 as the remainder. Quotient is 2. Okay, quotient is 2. That is correct. Now, whichever is the last number you have divided with, that number will become the quotient. Sorry, that number will become the HCF. So HCF of this whole process, after doing all the process, what is the HCF that we got? 5. Did you all understand? Let us solve one more problem. I think it will be much clearer. Now, find the HCF of 256 and 1166. So there are bigger numbers. Always have calculator with you handy. Not mobile calculators, but you should have one calculator along with you, which is very handy. Okay. Now, so the first step is going to be which is the bigger number. We have to identify which is the greater number. So 1166 is greater than 256. Correct? So 1166 is greater than 256. So we are going to, one second. Yeah, we are going to divide this 1166 by 256. That's not 2056 power, it is 256. That 0 is not there. Okay. So let us start. So 1166 will come in center. Okay. And then we have 256. Now, how do we know which number is divisible? Just multiply or just check 256 table. 256 ones are 256 twos are 256 threes are 256 fours are. Like this, you just check 1 2 3 numbers. Okay, how much do you get? 256 into 2 is 512. No, let us check 3. 3 is 768. 4 is 1024. 5 will become too much. We will go with 4. 256 into 4, 1024. Okay, 256 into 4. Let me just take out this part because place will not be enough. Okay, so 1024. Now, how much is the remainder? 6 minus 4 is 2. 6 minus 2 is 4. And we have 1. That 1 and 1 will go away. So 142 is the correct. 142 is the remainder. Now, which number am I supposed to take now? Good. Few of them have already solved. Lakshmi, 4 is not the answer, my dear. Please check once again. Yeah, 256. Very good. So 256, we will take it here. Now check 142 table. 142 into 2 itself will go 284. Right? Are you all able to understand? Yeah. So we'll stick with 142 ones are. Why we are not going 142 twos are? Because we'll get 284. So which is more than this. So we'll go with 142 ones are 142. Now subtract 6 minus 2, 4. 5 minus 4, 1. 2 minus 1 is 1. 114 we got. And then now which number should I take down? Which number should I take it down? 142. Now again, 142, I think it will only go with ones, right? So 114 ones, 114. 114 ones, 114. Now do the subtraction. So I'll take one borrowing here. So this will become 12. So 12 minus 4 is 12 minus 4 is quickly. Yeah, HCF is 2. 12 minus 4 is 8. And then we have 3. 3 minus 1 is 2. 1, 1 will go away. Okay. Next, 114. Now, which is the table that we will check? 28 twos or 28 fours. We can go with 28 fours. Yeah, HCF is 2. Very good. 28 into 4. 28 fours are 112. So what is the remainder that we get? I'll just add another page here so we can continue. Okay. So 114 minus 112, we get 2 as the remainder, right? So for 2, which is the number should I take it down now? 28. So 2 14s are 28, 2 1s are 2, 2 4s are 8, correct? So I get 0 as the remainder. Now I can easily say, since 2 is the last number where we got remainder as 0, so the HCF is equal to 2. Everybody understood? Yeah, many of them had given the answers and you were all right. Good. So we'll solve one more problem. Yeah, now give this a try. We have 3 numbers. Until now we had only 2 numbers. Now with 3 numbers, what are we supposed to do? We have to take 2 numbers at a time. Okay, we cannot go with 3 numbers at a time. You cannot divide 3 numbers at a time using the division method. So first choose first 2 numbers and find out HCF. After that, whatever answer you get, that will be one part. And then we will take that HCF and the third number and find out the final HCF. Okay, we will first solve, or we will first go with 210 and 385. As in when we do the problem, I will explain it to you. Okay, so let us start. Now out of 210 and 385, which is the smallest number? Which is the smallest number? 210. So 385 is greater than 210. So let us start with our division. So we will have 210 here and 385 here. Now which is the table that will go? To check with 210 ones are, 210 twos are. What is 210 twos are? What is the value of it? 420. So 420 is more than 385. So we cannot do anything. We cannot use 2. So we'll go with ones are. Okay, so 210 ones are 210. Subtract. Same with the remainder. You will get 5, 8 minus 1, 7, 3 minus 2, 1. Correct? You're supposed to subtract. Lakshmi, yeah, correct. Lakshmi, your HCF answer is right. Now use that HCF and 735 to find out the next HCF. Spurti, you are also correct. Yeah, good. 35 is the correct answer. Whoever has got 35 as the answer, now divide 35 and 735 to get the final HCF. Okay, others concentrate here. So 175 we have got. Now we are going to take 210. 10. Now here again I have to take 1s because 2s will become more. So that is 175. Yes. Now here 10. 10 minus 5 is, final HCF is also 35. Good. Okay, Aishu. Good. So 10 minus 5 is 5. Here it is 0. I'll take a borrowing again. 10 minus 7 is 3. So 35. Now I'm going to take 175 here. Now 35 into what is 175? 35 5s are 175. Just check 35 table, you will easily get. So I get remainder as 0. Okay. Yeah. So now the HCF here, the HCF of 210 and 385 is 35. This is first step. Now going on further, let me add another page. We will find out the HCF between, okay, we are going to find out the HCF between 35 and 735. Okay, so 735 will come in the center and 35 will come to the other side. Okay, so 735 by 35, it will go in 21 directly. Yeah, 35 into 21 is 735, where your remainder is 0. Good. So quotient is 21. But what is the HCF? HCF of 35 and 735 is also 35, because if you see here, you have 35. Okay, final answer, put a box, which is compulsory. Everybody understood? Any doubts in division method? Good. We will solve a few more, another 1 or 2 problems. Tomorrow I'll start a new concept. We will start few more or we will solve few more under division method. Okay, we will go with 3 numbers only. So this was 210, 385 and 735. Now next problem. Find the HCF of find the HCF of 513, okay, 1134 and 1215. Can you try this? 513, 1134 and 1215. I'll give you 2 minutes. Just give it a try and then I'll solve it. First solve 513 and 1134. Okay, and say me the HCF, and then we will solve 1215. Good, you are very fast. HCF is 27. Okay. Solve 27 and 1215. Okay. So the LCM between 513 and 1134 is 27. Correct. Final HCF also, sorry, final HCF is also 27. Everybody got the answer? Very good, very good. Anybody want me to solve this? Some of you will be there who will not be able to understand. Okay, we'll quickly solve. Now you people say me what all numbers I should use and we will quickly solve this. So first we will take 1134 and we have 530. Now say me which is the number. You will get the next sum, Pavan. Please wait. So 513 into 2 is 1026. Very good. Now what is the remainder I get? Remainder is 108. Okay, 108 and then I'm going to take 513 here. So now which is the number I should consider? 108 into 4. Okay, 108 into 4, how much I get? 432. Okay, so what is the remainder? Remainder is 81. Okay, next quickly, 108 I'm supposed to take. 81 ones are 81 ones are 81. So how much do I get? 27. Okay, 27 and then I have 81. 27 threes are. Okay, 27 threes are 81. So remainder is 0. Very good. So HCF is equal to 27. So this is HCF. This is HCF for first one. Okay. So let us go for the next one. Now we have 27 and along with 27, which is the other number, we have 1215. Okay, so we have, what is wrong with this? Okay, so we have 27 1215. 27 into 45 or 46? 27 into 45. Yeah, 45. 45 is 1215 and we get direct remainder 0. So very good. So you have HCF, the final HCF is also 27. Good. One last problem. Okay, one last. Yes, note submission. I'll send the message in the group. So don't worry. What is the date, when you have to send, how you have to send, everything I'll put a message in the group. Okay, now one last problem. Let us take, find the HCF of, I think this must be easy, 108 and then 288 and 360. Try this and say me the answer quickly. One 108, 288 and 360. So first solve 108 and 288. Get the HCF and then solve for 360 with along with the HCF. Very good. 36. Okay, find out the final HCF quickly. Final HCF is also 36. Good. So say me the answer now. So I'll take 288 and then we have 108. Yeah, correct. Final HCF is also 36. Good. Now help me solve this problem. 108 into 2 za. Okay, how much do I get? 108 into 2? 216. Okay, what will be the remainder? 72. Okay. Now next I'm going to take 108. Now 108 into 1. Sorry, 72 into 1 is it? Okay, 72 into 1 is 72. What is the remainder I get? 36. And now I take 72 here. Now 36 into 2. Okay, so 36 into 2 is 72 directly. So I get 0. So HCF here is 36. Good. Now going on further to the next part. That
can you check for product class C1? In product.
okay. So the final HCF is also 36 for the second part. And these are the problems for HCF under division method as well as under your prime factorization method. So until now, what all have we solved? We have solved problems of LCM under prime factorization method and division method. We have also solved HCF under prime factorization method and division method. Now, we saw the problems where we had direct numbers to be solved. Okay, so that would be your regular numbers. Apart from that, if at all we have the numbers in the form of P by Q. Okay, if we have numbers in the form of P by Q, then we will be, how do we go by such numbers? So that is what we are trying to do here. Okay, so for that we have a separate formula which we are supposed to use to calculate. So what is that formula? The formula is HCF and LCM of fractions are given by the following formula, that is HCF is equal to HCF of numerators. Now suppose you have 1 by 2 and 3 by 4. Now HCF of numerators, first only consider the numerators, okay, and you are supposed to find the HCF of numerators, okay, and then find the LCM of denominators. Okay, so find the LCM of the denominators and then we will consider that HCF and LCM and use this formula, that is HCF of numerators divided by LCM of denominators, and calculate the HCF value and LCM value. So when you see a problem where they have asked to find out HCF and LCM, but when you see the numbers, you realize that it is in fractions. Now in such scenario, you're supposed to use this formula, that is HCF is equal to HCF of numerators divided by LCM of denominators. And then when you are trying to find out the LCM, first it is going to be LCM of numerators divided by HCF of denominators. Now how to remember this formula? Now remembering formula is, if you have HCF here, If you have HCF here, the numerator also has HCF. So what is remaining? LCM is remaining. That will come in the denominator. Now check the other one. When you have LCM here, the numerator has LCM. And then what is left out? HCF. So which is going to come down here. Easy? Did you all understand the formula? Are you all able to understand? You guys have to reply. What happened? Find the HCF and LCM of 1 by 3, 5 by 6, 2 by 6 and 4 by 27. So all of these numbers are in the form of P by Q. So if you see here, it is 1 by 3, 5 by 6, 2 by 6, 4 by 27. Correct? Now, in this, can you all say me what all are the numerators? Which are the numerators? Which numbers are called numerators? Good. So, numerators are 1, 5, 2, 4. Correct? Now, what we will do is, we are going to find out LCM as well as HCF for this numerators. Okay? We are going to calculate LCM and HCF for all of this numerators. Okay, now let's do that. First, let us find LCM. LCM of 1, 5, 2, 4. You can do it together or you can do it separately. Let's do one thing. Let us use division method. I think that will make our things very quick. Okay, so here 1, 5, 2, 4. Okay, so 1 is already done. So we'll take 5 ones are, 2 and 4 is remaining. I'll take 2s are, 1, 1, 2 ones are, and 2 2s are. Okay, and I'll again take 2, 1, 1, 1, 1. So what is the LCM? 5 into 2 into 2. 5 2s are 10, 10 2s are 20. So LCM is 20. Good, many of them have got. Now let us find HCF for the same numbers. HCF of same 1, 5, excuse me, 1, 5, 2, 4. Now find out the HCF. For 1, it is 1 ones are. For 5, it is 5 ones are. For 2, it is 2 ones are. And for 4, it is 2 2s are. And then 2 ones are. For 1, it's going to be 1 into 1. For 5, it's going to be 5 into 1. For 2, it's going to be 2 into 1. For 4, it is 2 into 2 into 1. Correct? Now, if you see in all of this, you don't have anything common except 1. Correct? See, 1 is there in everything. 1 ones are, 5 ones are, 1 is there, 2 ones are, 1 is there. And then 4 ones are, last 2 ones are, 1 is there. Apart from that, there is nothing which is common. So, HCF is equal to 1. Did you understand? Did you all understand how to find the HCF here? Okay. Now, let us go back to the problem. So, we considered all the numerators and we found out LCM and HCF of numerators. Now, what are denominators? Which numbers are called denominators here? Three, 6, 6 and 27. Okay, 3, 6, 6, 27. Now we are supposed to find out LCM and HCF of these numbers. Okay, now let us go and find out LCM of 3, 6, 6, 27. We will use division method, which is easier for us. 3, 6, 6, 27. So I can go with 3. I can start with 3. Good. People are giving answers. Yeah. Start. 3 1s are 3. 3 2s are 6. 3 2s are 6. And 3. And 3 9s are. 3 9s are 27. So 3 9s are. Next. I'll go with 3 again. 2 2. 3 3s are. 3 1 2 2. 3 1s are. I'll take 2. 2 1s are. 2 1s are. 2. Now let us find out LCM. LCM is equal to 3 into 3 into 3 into 2. 3 3s are 9. 9 3s are 27. Into 2 will give me 54. Very good. So 54 is the LCM of denominators. Okay. Now same we have to find out HCF. HCF of 3. HCF is 3. Okay. Let us see. 3 6 6 27. Okay. So 3 3 1s are 3. 6 3 2s are 6. 2 1s are 2. Again I have 6. So 3 2s are 6. 2 1s are 2. 27. 3 9s are 27. 3 3s are 9. 3 1s are 3. Okay. So what are the numbers we get? For 3, it's going to be 3 into 1. For 6, it's going to be 3 into 2 into 1. For 6 again, it's going to be 3 into 2 into 1. And again for 27, it will be 3 into 3 into 3 into 1. So what all is common? Except 3, I don't see anything. Except 3 and 1, there is nothing common. So HCF is equal to 3 is common, 1 is common, which is nothing but 3. So HCF is 3. Good. Many of them are giving the answers. So everybody understood till here? Yeah, correct. HCF is 3. Any doubts? Okay. Now let us go to the final step. Now in the final step, we are supposed to calculate both HCF as well as LCM. So HCF is equal to HCF of numerators divided by LCM of denominators. Okay. HCF of numerators is equal to LCM of denominators. Now, can you say me what is HCF of numerator? 1. Okay, 1. And what is LCM of denominators? Denominators were 3, 6, 6, 27. So denominators were 54. So HCF of the number given is 1 divided by 54. So this is the HCF. Understood? Now, once you calculate HCF and LCM, it is just that you have to put the values in this formula. Now, we will calculate the LCM. LCM is equal to LCM of numerator divided by HCF of denominator. Okay, so what is LCM of numerator? 20. You will have to send me the answer. And HCF of denominator is 3. So this is going to be your LCM of the denominator. That's all is the answer. So you have to find out LCM and HCF of all the numbers that is given to us and then use this formula. Clear? Understood? Great. So let us go for another problem. Now here you're supposed to find out. Now we'll do one thing. We will find both HCF and LCM. I think that would be better. Okay. So find the LCM and HCF. Firstly, what is that you have to consider out of both of them? What should I consider? Should I consider numerator, denominator? Numerator. So what are the numerators here? Numerators are 9, 18, 12 and 21. Correct. And what are denominators? 10, 35, 25, 40. Now can you all try and find out LCM and HCF of both numerator and denominator? Give it a try. Find LCM and HCF of both numerator and denominator and then I will solve. Okay. So others keep solving. If there are any students who are attending the class for first time, please listen. I'm going to solve this problem. So you have numerators, which is 9. Sorry for that. Okay. We have the numerators 9, 18, 12 and 21. Correct? Yeah. Now, to find LCM of the numerators, we are using the division method. In division method, we are going to write all the numbers in the same row. Okay, we're going to write all the numbers in the same row. Now, after writing all the numbers in the same row, okay, Spurti has got the answer. 252 is the LCM and HCF is 3. Okay, go on, Spurti. For the denominator, you calculate. Now, here what is going to happen? Can we go with 3? Yes, Kavya, 252, correct. Yeah, now here we will start with 3. 3 3s are 9. And then 3 6s are 18. And 3 4s are 12. 3 7s are 21. We can go with 3 once again. 3 1s are 3, 3 2s are 6, 4 and 7 will remain as it is because I cannot take any number. And then I'll go with 2, 1 will remain, 2 1s are 2, 2 2s are 4, 7 will remain because it's a prime number. Then 2 1s are 7 will remain, 7 1s are. Okay, now to calculate LCM, it is 3 into 3 into 2 into 2 into 7. So 3 into 3 into 2 into 2 into 7 is 252. That will be the LCM. Okay. Now moving on further to find the HCF of the same numbers. HCF of 9 and then which were the other numbers? 18, 12 and 21. 9, 18, 12 and 21. Now for HCF we have to solve them separately. So 9, 3 3s are 9, 3 1s are 3. 18, 3 6 are 3 2s are 2 1s are. Then 12, 2 6 are 2 3s are 3 1s are. Then again 21, 3 7s are 7 1s are. Now if you see the multiplications here, for 9 it is 3 into 3 into 1. For 18 it is 3 into 3 into 2 into 1. For 12 it is 2 into 2 into 3 into 1. And for 21, sorry, okay, wait a second. For 21, it's going to be 3 into 7 into 1. Okay, so what is the HCF? 3, because there's nothing else common. So this was for numerator. For denominator, how much all did you get? Okay, you have given me the final answer only. Very good. Good. We will quickly do it for denominators. Denominators are 10, 35, 25 and 40. Oh, okay. So let me go to another document because this document has completed. Okay, say me the denominators. 10. What are the denominators? 10, 35, 25 and 40. Now, LCM of this is 10, 35, 25 and 40. We'll go with 5. 5 2s are 10. Yeah, 5 2s are 10. Then 35 by 5 is 7. 5 7s are 35. 5 5s are 25. 5 8s are 40. 2 1s are 2 4s are 7 and 5 will remain. 2 2s are 5 7 1. 2 1s are 5 7 1. 7 1s are and 5 1s are. So LCM is equal to, we just have to multiply everything. 5 into 2 into 2 into 2 into 7 into 5. How much did you get? 1400. Very good. That's correct. Now let's go to HCF. HCF of same numbers for 10, 2 5s are 5 1s are. Then 35, we'll go with 5 only. 5 7s are 7 1s are. Then we have 25, 5 5s are 5 1s are. Then we have 40, 5 8s are 2 4s are 2 2s are 2 1s are. So for 10, it is 2 into 5 into 1. For 35, 5 into 7 into 1. For 25, 5 into 5 into 1. For 40, 5 into 2 into 2 into 2 into 1. So HCF is 5. HCF is 5. Good. So let us find out HCF, which is HCF of numerator divided by LCM of denominator. So HCF of numerator is 3 and LCM of denominator is 1400. Is this correct? So this will be your HCF. Now going to LCM. LCM of numerator divided by HCF of denominator. What is LCM of numerator? 275. 275, 252. You will have to send me the answer because I cannot go back to the document. 252. Okay. 252 divided by 5. So this is the LCM. Clear? Everybody understood? Now I have to go back to the document for the next question. Okay. Now here is the next question. Now try solving this. You'll get 2 minutes. Try solving this. 2 by 3, 2 by 3, 16 by 81, 10 by 27, 8 by 9. Numerators are 2, 16, 10 and 8. Denominators are 3, 81, 27 and 9. Find both HCF and LCM of these numbers. Okay, LCM. Numerator, LCM is 80 and HCF is 2 or 3. Check properly. 2 is it? Okay. Okay. Now go on and find for denominator. Okay, LCM is 80 and HCF is 2. Okay. Okay. So before starting the statement problems, we are supposed to understand few rules which will help us in solving the problems easily. Okay. So we'll just go through few rules which is required for now because we will be solving problems for all the rules here. Almost all the rules we will be covering the problems. So whichever rules are required as of now, only those rules I'll be discussing. And we will solve that problem. And then again, when next class, maybe we will come up with one more rule and then we will solve the problem. So that will help you understand every rule very clearly. Okay. So first, see this second rule. Okay. The second one. In case of HCF, if some reminders are given, then firstly, those reminders are subtracted from the numbers given and then their HCF is calculated. Now what they will do is, they will usually ask problems like, find the largest number, okay, find the largest number which subtracts, or sorry, which divides, they'll give 3 numbers and then they will say it will leave a reminder of 2 at the end. Okay, in such scenarios, how do we solve the problem is, we will first subtract all the reminders from the numbers, and then we will calculate HCF. Okay, to understand this better, let us solve one problem first, and I will understand using this problem, I will help you to understand the rule. Okay, so let's read the question. Find the greatest number which can divide 284, 698, 1618, leaving the same remainder 8 in each case. Okay, so what they are trying to say here is, we have to find one greatest number. Okay, one greatest number which will divide 284, 698 and 1618. Now that number, when you divide with the three numbers given here, it is supposed to leave a remainder of 8 in each case. Okay, so this is the problem. Did you all understand the problem first? Now in such problems, what are we supposed to do is, the step number 1, what we write is, the given numbers are, first we will write whatever is given to us. Okay, one second. The first step for us is to write down whatever numbers we have. So the given numbers for us are, okay, the given numbers for us are 284, and then 698, and then 1618. Okay, so this is the first step that we are supposed to write. Now after this first step, the next step what we are supposed to do is, we have to remove this 8. Okay, this remainder 8, whatever is given to us, we have to remove that from all the three numbers that is available. Okay, so the next step what we are going to write is, the HCF of the numbers. Okay, HCF of the numbers. Now which are the numbers that we are supposed to do? First one will be 284 minus 8. Okay, why minus 8? Because there is a remainder. This remainder you are supposed to remove previously only. Next, what is the other number? 698 minus 8, which will give you 680. Let's write down that final answers also. And here how much do you get? 276. 276 we get. Then the last number, 1618 minus 8. How much do we get? 1618 minus 8? 1610. Yeah. Now, so the next step, the first step is for us to write these given numbers. And then the next step is, we have to remove the remainder, that is 8, that is given in the question, from the three numbers that we were supposed to solve. Now you have 276, 680 and 1610. Now find the HCF of all these three numbers. You can use division method or you can use factorization method and find out. Now for now we will be using factorization method. Okay, sorry. Yeah, 690, that is just got missed out. Okay, so that is 690. Now let us use prime factorization method and we will solve it. Okay, so firstly, We'll just erase all this so we get enough space to actually solve the problem. Okay, so let us start. So first is 276. Now how do you start 276? From which table? 2, okay. 2 ones are, and then 2 threes are 6, 16, 2 eights are 16. Okay, then 2 6 are 12, 1 reminder 18, 2 nines are 18. Then 2 into 20, 2 twos are, sorry, 2 threes are 6. Oh, oops, I cannot go with 2. That is 69. So I have to take 3. 3 twos are 6, 3 threes are 9. Now 23 is a prime number. Any table do you get 23? No. So 23 ones are. 23 ones are. Next, 690. I think we can start with 3 also. 3 also will give us the answer. 3 twos are 6, 3 threes are 9, and 0. And then where do we go? To, if you take 3, we will not get the answer. I think we'll have to go by 2 only. We can go by 2. 2 ones are 10, 2 fives are 10. You get 115. And then now we will go with 5. 5 twos are 10, 5 threes are 15. Again you get 23. So 23 ones are. Are you all able to follow? Next, 1618. We'll start with 2. 2 eights are 16. Now next I have 1. But I'm supposed to take 2 numbers. Next 2 numbers I'll take. So I'll add a 0 here. Then, oops, sorry, 1610, right? We are supposed to take 1610. Okay. So the next 2 numbers, if I take, it will be 5s are. 2 5s are 10. Next, again 2. Will it go with 2? Think properly. How it will go with 2? 2 4s are 8. Then you have 5 at the end. If you have 5 at the end, you cannot divide that by 2. We will take 5. We'll take 5. 5 ones are 5. And then you have 1 at the carryover. So 5 twos are 10. Okay, just wait a second. 5 twos are 10. And then we have 5 ones are 5 again. Correct? Oops, sorry. Something went wrong. Just wait a second. 5 ones are 5. 6 7 8. We have 3 carry. So 30. Yeah, you're right. 30. 3 when we carry 3. Now you will have 5 6 are 30, and then 5 ones are 5. Sorry for that. Okay. Now 161, from which table will it go? 5? No, 5 it doesn't go. 161 will not go in 5. You get point. It will go in 7. Okay, 7 into 23. So 7. What is wrong? Just a second. Something is wrong here. Okay, 7 23. And then we have 23 ones are. Now, by just seeing this calculation, you will be able to identify the common numbers which are present, right? See, if you see 2 is present in every other number, factorization. 23 is present, very good. 2 is also present. Now, can I say HCF is equal to 2 into 23? So how much do I get? 2 into 23. I get 46. Correct? I get 46. So the required number, okay, the required number which is greatest number. See, if you see here in the first line, it says greatest number, right? The required greatest number which can divide 284, 698 and 1618 is nothing but 46. This is the required greatest number. Okay. Now what they are saying is, when you divide 284 by 46, now calculate 284 by 46. You get some you get some points there. Excuse me. Yes. Now again, sorry, you are supposed to divide not 284 but 276. You have these numbers, right? If you see 276, I'll add another page. 276 by 46, how much do you get? 6. Then 690 by 46, how much do you get? Calculate. 15. And then 1610 by 46, how much do you get? 35. Yes. Now what we are trying to say here is, we have these three numbers without point. Okay, without point, which means there is no remainder. There is no remainder. Okay, but if you take the original numbers in the question, you will have some points, which means there is a remainder. So one thing what you have to understand is, when there is no remainder, which means the numbers are completely divisible. Okay, but when you have any point, let's say you have 6.82, which means there is a remainder and it is not completely divisible. Are you all able to understand? Are you all able to understand? Okay, good. Now we will complete this with the procedure there. Okay, so what was the factors for 276? We had 2 square into 3 into 23. Correct? Then 690 is 2 into 3. Is that what we got? No, 3 into 2 into 5 into 23. 3 into 2 into 5 into 23. Okay, and then for the last one, 1610 is equal to 2 into 5 into 7 into 23. So HCF is equal to 2 is common and the least power of 2 is 1. Excuse me. And then 3 is not common. Right? 3 is not common. 5 is not common, 7 is not common, 23 is common. 23 to the power 1, which will give us 46. Therefore, the required number is 46. Now in statement problem, always write the In the statement problems, always write the final conclusion. That is how you will be able to say to the examiner or the evaluator, see, I have got the correct answer and this is what is the answer. Understood? Everybody understood? Anybody has doubts in the first problem? We will solve one more problem. Okay, we'll solve one more problem. I think that will make it much clear for you. Similar one, very similar one. Find the greatest number. See, for HCF, it is usually asked as greatest number. Okay, find the greatest number that divide 132 and 77, leaving remainder 2 in each case. Now, what do you think is the first step that we are supposed to do? What is the first step that we are supposed to do? Subtracting the number 2. No addition. You're not supposed to add anything. It's only subtraction. Yeah. So every question, first write what is the numbers given. Okay. The given numbers are 132 and 77. Okay. Now 132 minus 2, which is 130, and 77 minus 2, which is 75. Correct. HCF of 130 and 75. Okay, this will be my next step. I am supposed to find the HCF of 130 and 75. Now, first let us find the HCF of 130. 130. Already found out? Very good. Now 130, from which I should start? I can go with 2. 2 6 are 12. Yes. 2 6 are 12 and then 1 carried over. 2 5s are 2 5s are 10. And then we'll go with 5. 5 1s are 1 carry over. 5 3s are 15. And then we have 13. 13 1s are. And then which is the other number? 75, right? So we'll start with 5 directly. 5 1s are 2 carry over. 5 5s are 5 3s are 3 1s are. So for 130, 2 into 5 into 13, and for 75 I have 5 into 5 into 3. So HCF is equal to 5 is common. Yeah, only 5 is common. Correct. So therefore the required number is 5. If you still want to check out, divide 130 by 5. You will get proper multiplication, proper division. 75 by 5, you will also get proper number, a whole number, and nothing with points. In that case, the required number is 5. So 5 is gonna divide. Okay, 5 is gonna divide 132 and 77 where it is gonna leave 2 as remainder in each case. Understood? Any doubts? We will solve one more problem. You people will try one more problem. Take down. Find the greatest number by which if 1657 and 2037 are divided to get a remainder. Okay, reminders 6 and 5 respectively. Can you give this a try? 1657 2037, but reminders are given separately. Okay, reminders are given separately, that is 6 and 5. So 1657, how do you do? First write down given. Okay, and then 1657 minus 6, because the remainder is 6, and then 2037 minus 5. See, it says respectively. Respectively means 1657 and then minus 6, 2037 minus 5. Now, what is the answers you get here? 1657 minus 6 will give you 1651, and 2037 minus 5 will give you 2032. Now find the HCF of this. Find the HCF of this. Keep trying. Okay, please write the steps and then solve the problem. So here the HCF is 127 and the required number is 127. Clear? Any doubts? Then let's go to the next problem. Okay. Now next we firstly solved HCF, right? Now we will solve similar problems in LCM. Now in HCF, what did we do? We subtracted the reminders first and then we found out the HCF, correct? Now let us see how to solve them under LCM. Now in LCM, what is going to happen? How to identify it as LCM is, the question will say least number. Okay, you're supposed to find the least number which when divided by 6, 10, 15, 30 leaves no remainder. Okay, here they are saying leaves no remainder. No remainder means no need to subtract, add anything. So firstly, what you're supposed to do is write down given numbers are 6, 10, 15 and 30. Okay. Now the next step, you are supposed to find the LCM of 6, 10, 15 and 30. Okay. 6, 10, 15 and 30. Now can you find the LCM and say me the answer quickly? Use division method and find the LCM. So we'll start with 2. 2 3s are, and then we have 2 5s are 10, 15 I can't do anything, then 2 15s are 30. Good. Many of them are giving answers already. Then I'll go with 5. 3 remains, 5 1s are, 5 3s are, 5 3s are. Then I'll go with 3. 3 1s are, 1 remains, 3 1s are, 3 1s are. So LCM is equal to 2 into 5 into 3. 5 2s are 10, 10 3s are 30. Okay. So 30 is the required number. Required number is equal to 30. That's all is the answer. Now here the problem says leaves no remainder. Since it says no remainder, we are not adding or subtracting anything. We will just find LCM, and that LCM number will be the least number which will divide 6, 10, 15, 30 and then will not have any remainder. Understood? Did you all understand this problem? Okay, we will solve one more problem similarly, but here there is remainder of 2. Okay, so first step, given numbers are 18, 24, 56. Okay, now in LCM, we will first find the LCM and then I will teach you what is to be done with the remainder. Okay, so first given numbers are 18, 24, 56. So let us find out LCM of 18, 24 and 56. Okay, so 18, 24, 56. Can you solve this and say me the answer quickly? We'll start with 2. 2 9s are 18, 2 1s are 2, 2 2s are 4. Then again 2 2s are 4, 16, 2 8s are 16. Then again I can go with 2, 9 will remain, 2 6 are 12, 2 14s are. Then I can go with 2 again, 2 3s are 6, 2 7s are 14. Then I'll go with 3, 3 3s are, 3 1s are, again with 3 and again with 7. Okay, so what is the LCM that I would get? LCM is equal to 2 into 2 into 2 into 3 into 3 into 7. So how much I get? 504. Good. 504 is what I get as LCM. Now, what does the question say? The question says it leaves a remainder of 2. Correct? It leaves a remainder of 2. Now, what we are supposed to do is Write down below that. Now, when 504, okay, when 504 is divided by 18, and then we had 24 and 56, we get no remainder, correct? We don't get any remainder because it is properly divisible. So therefore what do we do? If the number, okay, if the number 504 is increased by 2, it will leave remainder 2. Okay, so the required number. Now in this problem they have given us HCF of two numbers is 16 and their LCM is 160. If one of the numbers is 64, find the other number. Now here what is happening is, if one of the numbers, okay, if one of the number is 64, and if we find the other number, then in that case we can use the formula directly. Okay, we can use the formula directly. Now before I let us continue. Now here the formula goes like this. If you remember the formula, we had written HCF of two integers are related by the following formula. HCF and into LCM into HCF is equal to product of the integers. Now here in the current problem they have given us HCF as well as LCM, and out of product of integers we know only one integer, and the other integer we are supposed to find out. So we are going to use this first formula here to find out the other number which we require. Okay, going back to our problem. Now let us write down what all is given to us. Okay, so given HCF is equal to 16. Okay, good, few are solving it already. And then we have LCM is equal to 160, and then if one of the number is equal to 64, so what we will do is we will start with the assumption. Let the numbers be A and B. Therefore, A is equal to 64, B is equal to question mark. We are supposed to find out what is B. Fine. So we are going to find it out. Now write down the formula. What is the formula? LCM. Okay, let me use a different name for the formula. LCM into HCF is equal to product of integers. Integers is denoted by Z, so product of integers. So what is LCM? What is LCM given to us? Quickly, I want everyone to answer. What is the LCM given to us? 160. And what is the HCF given? 16 is equal to product of integers are nothing but A into B. Okay, so 160 into 16 is equal to 64 into B. So what is 160 into 16? 960. 160 into 16. 16. 2560. So 2560 is equal to 64B. Now what are you supposed to do? Continued with this. Now we had 2560 is equal to 64B. Now I can take 64 to the other side. Now here it is multiplication. When I take it to the other side, it will become, what will it become when I take multiplication to the other side? Division. Very good. Divided by 64 is equal to B. So what is the answer? 2560 divided by 64. 40 is equal to B. So therefore, the other integer is 40. Everybody understood? Okay. Let's go to the next problem now. Now, read the... Okay, Gauri wants it to be repeated. We'll quickly do it. I'll quickly revise the problem once again. Listen carefully. Now here they have given us HCF of the number and LCM of the number. And out of the two numbers, one number is 64. And the other number is, we do not know. Okay. So we have considered A as, we have considered A as 64 and we do not know B, so it is question mark. Now we will use the first formula that we have learned in the previous class, that is LCM into HCF is equal to product of integers. Now instead of writing integers full form, I have written it as product of Z. Z is a short form where we denote that for integers. Okay. Now what is the LCM that is given in the problem? 160. And what is the HCF? 16. So 160 into 16 is equal to product of integers. So there are two numbers. One of the number is 64. Correct? So A, I have taken it as 64. And B, I do not know. So I keep it as it is. 160 into 16 is 2560. And the other side, 64 into B, I will keep 64B as it is. Okay, 64B is kept as it is. Now continuing that calculation, 2560 is equal to 64B. Now here you have multiplication. Now when I take it to the other side, it is going to become division. Okay, so 2560 divided by 64 is equal to B. When you divide these two numbers, you get 40 as the answer. So which is nothing but the other integer B is equal to 40. So therefore we got the answer which they had asked in the question, that is nothing but find the other number. Okay, find the other number which is nothing but 40. Now is it clear? Can we go to the next question? Yeah. Now, you will be solving this question. It's a very easy question. I will first explain you what is to be done and then you can give it a try. So listen carefully. 3 vessels can hold 9, 15, 24 liters of water. Okay, so there are, let's say, 3 vessels. Okay, so there are 3 vessels which can hold 9, 15 and 24 liters of water. This is what is given to us as the first information. Now next, find the least quantity. This is very, very important word. Underline that later also. Okay. So they are asking us to find the least quantity of water which can be filled by these vessels an exact number of times. And I've told you that the least quantity, whenever you get least or minimum in the question, if you get that word in the question, you can take it as LCM and solve it. Now in this question, what are you supposed to do is just find the LCM of the 3 numbers 9, 15 and 24. Now once you find the LCM, that will be the least quantity of water that can be filled in these vessels in the exact number of times. Will you give it a try? Now find out the LCM of 9, 15 and 24. $360. So few are getting different answers. 180 and somebody else got 9 also. So please check. Analyze once again what might be the answer. $315, $360, $180. Okay, let us check. Okay, now we will solve and we will check what is the answer. Let us find LCM of 9, 15, 24. Okay, so 9, 15, 24. You can use division method. There's no problem. Okay, so first which table we will start? 2 or 3? 3? Okay, fine. We'll start with 3. And what are the numbers that I get? 3 3s are 9, 3 5s are 15, 3 8s are 24. Now next, 3 1s are 5, I'll keep it as it is. 8 I cannot do, I'll keep it as it is. Then 5 1s are 5 and 8 as it is. 2 4s are 8, 2 2s are 4, 2 1s are 2. So your LCM is supposed to become 3 into 3 into 5 into 2 into 2 into 2. So now how much did you get? 3 into 3 into 5 into 2 into 2 into 2. You get 360. So your LCM is nothing but 360. This is your answer. Now, how do you know you have to solve it using LCM? This line. The least quantity of water which can be filled by these. The least, which when the word says least, then you're supposed to use LCM. Clear? Understood? Now, people who had got the numbers 315, 180, please check where you have gone wrong. Which step you might have gone wrong, because many students do silly mistakes in calculating LCM and HCF. They will get confused between LCM and HCF firstly. So please make sure you check where you're going wrong and then you solve it. Now write down the conclusion for this. Such statement problems, conclusions are very important. Okay, you have to write down the conclusions. So write down. Therefore, 360 liters of water can be filled by these vessels an exact number of times. This is supposed to be your conclusion. Clear? Understood? Can we go for the next problem? Now, three bells call at interval 30 seconds, 40 seconds and 50 seconds respectively. They start together. After how many minutes will next bell fall together? Now here you don't have the word least, okay, but the main catch of the problem is this word together. Okay, when you have the words like together, simultaneously means again it means together. Okay, it means together. So yeah, again here you have start together, correct. In that place also, when you have these words, it is LCM. Okay, so they have three calling bells which has an interval of 30 seconds. One has an interval of 40 seconds, the other one has an interval of 50 seconds. Okay, now they are going to start together. All the three of it will start together. Now they're asking after how many minutes? See this. After how many minutes will next bell fall together? Let's say now the time is 9:23. At 9:23 they will ring the bell. All the three bells will ring at a time. Now they're asking after how many minutes the next bell will again fall together. Okay, so let us solve this. Now since we have together as the word which is being used in the problem, we are going to use LCM for this problem. So we will be solving LCM for these three numbers, that is 30, 40 and 50. Now once we solve the 30, 40 and 50, whatever LCM we get, that will be the we'll do a little calculation and we will know after how many minutes the bell is going to ring. Okay. Now, can you all solve the LCM quickly? Let us find the LCM of 30, 40, 50. So we'll start with 10. 10 threes are, 10 fours are, 10 fives are. You can go with 2 also, no problem. You can go with 2 also. 3 ones are, 4 and 5 remains. 5 ones are, 2 twos are, 2 ones are. Okay, so my LCM is equal to 10 into 3 into 5 into 2 into 2. So how much do I get? If you have started the calculation with 2, no problem. Then also it is correct. 10 into 3 into 2, sorry, 5 into 2 into 2. We get 600. Okay, 600 seconds. This is 600 seconds. Because if you see here, 30 seconds, 40, 30, 40 and 50 are in seconds. Correct? So this is 600 seconds. Now we are supposed to convert this into minutes. Now I'll just go to the next page. We have 600 seconds as the answer. Correct? Now let us see how do we convert that. Hence, the bells will fall together after 600 seconds, or 600 divided by 60. How much do you get? 10 minutes. 10 minutes. Did you all understand? So we are converting the seconds to minutes. 600 by 60. Okay. So after 10 minutes, again, all of the bells are gonna, all the 3 bells are gonna ring simultaneously, or they're gonna start together. Understood? Can we go for the next problem? Yeah, we are back to the reminders problems. Now, find the least number when divided by 5, 6, 8, 9, 12, leaves a remainder 1 in each case, but when divided by 13, leaves no remainder. Okay, so firstly, say me, what are we supposed to find out? Is this an LCM problem or a HCF problem? LCM? Everybody now understood how to find out LCM and HCF problems? Because it clearly says find the least number. Now, so let us start. Let me change the ink color. Let us find the LCM of 5, 6, 8, 9 and 12. Start calculating. 5, 6, 8, 9, 12. So we'll start with 2. 5 will remain. 2 3s are 6. 2 4s are 8. 9 will remain. 2 6 are 12. Then again 2, 5, 3, 2 2s are 4, 9, 2 3s are 6. 3. 5 will remain. 3 1s are 2. 3 3s are 9. 3 1s are. Again 3. 3 1s are 2, 1, 5 remains. So 2, 5, 1, 1, 1, 1 and lastly 5 and 1 everywhere. Okay. Now how do we find the LCM? LCM is equal to 2 into 2 into 3 into 3 into 2 into 5. Everybody got the answer as 360? 2 into 2 into 3 into 3 into 2 into 5. Yes, everybody got it as 360. Okay, so our LCM is 360. Now, what is the question? Let us read the question once again. Find the least number when divided by 5, 6, 8, 9, 12 leaves a remainder 1. Okay, until that leaves a remainder 1 in each case. Okay, until this we will first solve it and then we will go for the second part. Now, we have found the least number, that is 360, which is that 360, will it leave a remainder 1 or not? We have solved a similar problem before. Okay, but when we calculate LCM of a number, do they leave a remainder 1 or the remainder will be 0 for 360? Say me the remainder will be 0 or 1. Guys, understand. Now what are the numbers? 5, 6, 8, 9, 12. Okay. So 360 by 5. What is the answer you get? What is the answer you get for all this? 360 by 5 is 72. 360 by 8 is 360 by 8. You get 45. 360 by 9 is 40. 360 by 12 is 30. Now, out of any of these numbers, do you find a point? Do you find point? Everything is a whole number? Everything is a whole number here. There are no points, which means there is no remainder. Which means there is no remainder. So when you do when you take LCM number, there will be no remainder. So whatever remainder you want, 1, 2, 3, 4, 5, 6, whatever remainder you want, you are supposed to add that to the LCM number. Now here we require the LCM, we require the number to leave 1 as remainder. So therefore, the required number is equal to 360 plus 1, because we want 1 as remainder, which is nothing but 361. Understood till here? Anybody has doubt until here? Now, let us go back to the question. That was only first part. We still have a little more left out. But, see the second part. But when divided by 13, leaves no remainder. Okay. When that least number, when you divide by 5, 6, 8, 9, 12, will leave a remainder 1. But when you divide that by 13, it will not leave any remainder. Let us check that if that is happening or not. Now, 361, let us try and divide it by one number. Let us say 5. Let us divide this by 5. Okay. Now, from which table will it go? It will leave a reminder. We will do the division. Yeah, you get, I understand you get a point, which means it will leave a reminder. So let us understand it leaves 1 as reminder. Okay. 5 7s are 35. You will have 1. Correct? And this 1 will come down, which is 11. 5 2s are 10. 1 is the remainder. See, this is a reminder. Correct? This 1 is reminder. We are getting reminder like this. You can check for all the numbers. 5 and then for 6, for 8, 9, 12, you can check all of the reminders. There's no problem. Now, what we will do is, we will divide this 361 by 13. Okay, now this was our first condition where it is supposed to leave a reminder 1. It is done, it's verified. Now our second condition is, if you divide this 361 by 13, it should not leave any reminder, which means your reminder is supposed to be 0. Okay, now let us try this. Let us see how it is going to work. So 361 13. Now from which table do you think it will go? We'll start with 2. So 13 into 2 is 26. So we have 10, and then this 1 is going to come down. Okay. Now next, 13 into 7 is 91. Now 101 minus 91 is 10 again. Okay. Now what we will do is, 13 and 10, it will not go. Sorry, I forgot this 7. So what we will do is, we'll keep one point. When I keep a point, I am going to add a 0 here. Now again, I will go with 7, which is 91. Now how much do I get? 9. Correct? I get 9 again. So what I do? I can go with another 0 for 90. So how do I take 90? 6 are 78. Now what is the difference? 13? Okay, we are getting 12. Wait a second. Yeah, you're getting 12. Somewhere there's a mistake, might be. Three 16, 13 twos are, and then 10, 1 will come down. So 13 sevens are 91, 10, and then yes, I will solve it once again. Wait, let us check where the numbers have gone wrong. I found the answer yesterday correctly. I don't know what's wrong. Yeah, the answer is 27.79. Okay, so this problem which we started yesterday. So find the least integer which when divided by 18, 24, 56 leaves a remainder 2. Now in this, what did we do first? We first found out LCM. Okay. Now we found out LCM. Yes or no? Now after finding out LCM, what did we do? We found out that one number which, one second. Okay, so we found out one number where that number which when divided by 18, 24 and 56, we got one, the remainder of 2. Now let us understand only this last part. Yeah, 504 is the LCM which we found, correct. Now the last conclusion what you're supposed to understand is when you take this 504 number, okay, and now how did we get LCM? One main point you're supposed to understand is the LCM number which you get, 504. This 504 number will not leave any remainder. It is completely divisible. So that is why you get that as an LCM number. Now in the question they're asking us clearly, find a number which leaves remainder 2. So which simply means that, okay, which simply means that LCM 504, if I add 2 to this, okay, if I add 2 to this, that will become 506. Then this number 506 will leave a remainder 2, because this extra number added. Okay, in HCF what did we do? We subtracted the remainder and then we found out HCF and then we got that number. That is how you solve under HCF. When it comes to LCM, first you have to find out LCM and then whatever remainder you want, because this is least common multiple. The full form of LCM is least common multiple. So it is the least number that you will get. So that is why whatever remainder you require, you're supposed to add that remainder to the LCM number to get the required number. Are you all able to understand? Did you all understand what I was trying to say? Yeah, I will repeat it, Aishu. Now in this problem, what is that which is happening is, it's an LCM problem. They have asked us to find out the least number, okay, which when we divide 18, 24, 56, we should not, we have supposed to get remainder 2. Now read the conclusion here, this one. Now, when 504 is divided by 18, 24, 56, we get no remainder. Because LCM is the least common multiple, which will not give us any remainder. Are you clear until that? When you divide 504, when 504 is divided by 18, 20, 24 and 56, let us find it out also. Let's not get confused so much. 504 divided by 18, how much you get? What is the answer you get? $28. Everybody got 28. So you're not getting any points. If you get a whole number, it means there is no remainder. Okay. Now, next, 504 divided by 24. What is the answer that you get? 504 divided by 24, 21. Everybody has got 21? Everybody has got 21. Good. Now, once again, 504 divided by 56. 9. Everybody has got 9. Now, if you see the reminders, they are whole numbers. You don't get anywhere, anywhere you don't get a point. Correct? So, which means that 504 number, okay, that can be divided by 18, 24 and 56 without any remainder. But according to the question, we are supposed to get remainder 2. 2 is supposed to be the remainder in each of the case when we divide them. So what we are going to do here is, for this 504, okay, for this 504, I am just going to add 2 because I want 2 as remainder. So what will be my required number be now? 506. Yes, 506 will be the required number. Now you're supposed to divide 506 by the 3 numbers. Do the actual division and check. Then you will find the 2 remainder. But did you understand why we got 506? Why did we add 2? Everybody understood? Everybody have to reply. Okay. Now let us solve one more problem, one more similar kind of problem with remainder, and then we will go to the new concept. Okay. Now going on further, find the least integer which when divided by 6, 10, 15, 30 leaves the remainder 2. Now here also in this case it is 2. To make it easier, we have taken this problem. Now what is the first step I am supposed to do? How do I start the problem? Given very good, six, 10, 15 and 30. Yeah, given numbers are 6, 10, 15 and 20. LCM of 6, 10, 15 and 30. Correct? Now can you all find the LCM? Yeah, correct. Given numbers are 6, 10, 15 and 20. Sorry, 30. Now find out the LCM using division method because it is easier and it is time saving. Okay, so we will start finding LCM. LCM already found. Good. So which number should I start with? I'll go with 2. Okay. We'll change the color here. 2 3s are 6. 2 5s are 10. I cannot do anything, but then 15 has to remain as it is. In case of 30, let me write it properly. In case of 30, I can take it as 15. 2 1s are 2 5s are. Then what is the next one? I can go with 3. 3 1s are 5. 3 5s are 15. 3 5s are 15. Then 5. 5 1s are 5 1s are 5 1s are. So LCM is equal to 2 into 3 into 5. 2 3s are 6. 6 5s are 30. So LCM is 30. Very good. You also got the required numbers. Good. You people are quite fast. Now, let us write the conclusion. Now, when 30 is divided by, which are the 3 numbers that we had? Which were the 3 numbers that we had? 6, 10, 15 and 30, correct? 6, 10, 15 and 30, we get no remainder. You have to write this conclusion. 6, 10, 15 and 30, we get no remainder. Therefore, if the number 30, it's like you're explaining it, okay? If the number 30 is increased by 2, then it will leave a remainder of 2. Therefore, the required number is 32. Understood? The normal 30 that we got, it was not leaving any remainder. Now I add to this and then I get 32. So now I get a remainder of 2 when I divide them. Everybody understood, right? So, and one thing that you have to note in the problem is, When they are saying least integer, calculate LCM. But the same thing when they are talking about highest integer, calculate HCF. Okay. Usually least integer is what? LCM, and highest integer is HCF. Clear? Can we go to the new concept? Yes. Now, the next concept under same HCF and LCM, I think probably the last concept here, okay, is when you have both LCM and HCF given, and there are quite different type of problems that we will be solving. Okay, not too complicated. We'll just understand each of them one by one. Now, firstly, the HCF and LCM of two integers are related by this formula. When they give you both HCF and LCM, how do you find the values? So first formula, this is one formula. Let's understand this. LCM into HCF is equal to product of integers. So let's take an example. We have 4 and 6. Okay, example only. These are 4 and 6. Now let's say we are supposed to find the LCM of 4 and 6. Now can you say me what is LCM of 4 and 6? Calculate LCM of 4 and 6. Any method you can use, that is up to you. So what will be the LCM? 2 2s are 4, 4 3s are 12. Okay, LCM is 12. Now can you find the HCF of 4 and 6? I get 2 into 2 and then 2 into 3. So I can say HCF is 2. Yes. Now we got HCF as 2 and LCM as 12. So everybody remember this. HCF is 2 and LCM is 12. I'm going to clear this part of calculation. Now let us understand. Now let us understand this formula, first formula. Now what is LCM? 12. 12 into 2. LCM was 12, HCF was 2. And what were the integers that we took? 4 and 6. 4 and 6. Now find out the product. 4 6 are 24. 12 2s are 24. You are getting the same answer? That is the meaning of the first formula. Now out of this three data, LCM, HCF and product of integers, okay, LCM, HCF and product of integers, one of the data if they don't give us, say suppose they have not given us LCM, okay, then we will see how to find the values. Now we don't know what is LCM, okay. Now when we do not know what is LCM, let us see how the formula goes. We are going to keep the same product of integers. The product of integers remain as it is. And this HCF, which had multiplication sign here, I am going to take it to the other side. Okay, is after is equal to, if I take it, I have multiplication sign one side. If I take it to the other side, it will become division. Understand this better. When I have multiplication and I take it to the other side, it will change the sign completely. So it will become division. Suppose if I had plus here and if I take it to the other side, it will become minus. If I had minus here and if I take it to the other side, it will become plus. Okay. If I have division in this side and if I take it to the other side, it will become multiplication. Clear? So if it is division, it changes to multiplication. If it is multiplication, it changes to division. If it is plus, it becomes minus. If it is minus, it becomes plus. That is the basic you have to remember. Okay. Now here, what has happened? I have changed multiplication to the other side. So it becomes division. So HCF comes down. So product of integers divided by HCF. So this is second formula. You can either use first or second formula to solve the problems. Everybody understood? Okay. Now let us go to the problems. Okay, we'll go to the problem and they will solve one of the problem. Now, read the problem thoroughly first. The sum of two numbers is, the sum of two numbers is 216, 216, and their HCF is 27. Now first let us assume few things here. Let the numbers be A and B. We don't know what the numbers are. They're just saying the sum of two numbers is 216. And the HCF of the numbers are 27, and we are supposed to find the numbers. Okay. Let the numbers be A and B. This is the first assumption. Now, when we are talking about HCF, okay, when we are talking about HCF, this 27 is common with both A as well as B. Yes or no? 27 will be common with both A as well as B. For people who did not understand, we will go back to our same, first one, 4 and 6. Now when you found the HCF, 2 2s are 2 1s are, 2 3s are 3 1s are, 2 into 2 for 4, and for 6, 2 into 3. Here 2 was common in both of them. Correct? Now suppose say this is my number A and this is my number B. Now since 2 is common in both of them and my HCF is also 2, 2 is multiple of 4 and 6. Now I can write them as 2 into A and 2 into B. Can I write it like this? I have got HCF as 2. Now this 2 I am multiplying with A and I am multiplying it with B also. Everybody will agree with this? Did you all understand this part? So when you get a HCF, because it is the common factor, you can multiply that with the numbers that is being given in the question. Now since the numbers here are A and B for us, what we are going to do is we will multiply this with the HCF. So therefore numbers are 27A and 27B. Everybody will agree with this? 27A and 27B. Okay. Now we understood the numbers. Now what is the first information given to us? The sum of two numbers. Sum means addition. So sum of two numbers. Now the sum of two numbers is 216. Okay, sorry for the bad handwriting. Okay, then sum of two numbers is 216. So I can write it like this: 27A plus 27B is equal to 216. I can write it like this, right? Yeah. So 27 A plus 27B is 216. Now just check if I can take out any common numbers. Any number is common? $27 is common. Good. 216 by 27 will give me 8. So I can take out 27 from the equation completely. Now if I take out 27 from the equation completely, 27 ones are. So I will have A only remaining. See, people who are not able to understand, what I'm doing is I'm dividing 27 from the whole equation. 27 divided by 27 divided by 27 divided by 27. Now what do I get? 27 by 27, I get 1A. Okay, so this 1 is not required to write, so I only will write A. Then 27 by 27 is 1 again, I get B is equal to 216 by 27 will give me 8. So this is my simplest form of equation. This was the first equation. Second one is the simplest form of equation. Yeah, correct. 216 by 27 is 8. Now, what are you supposed to find? Until here, everybody understood before I continue? Okay, great. Let me add a page here. Now, what happened is I have a equation A plus B is equal to 8. Now, I have to find out in using the tables, I'm supposed to find out all the possible options where I can get 8. Okay. Now, let us check. Now, here, one second. I'm supposed to find out 8 when I add them. Now I have to get two numbers, right? When I add them. Now which all possibilities can I get where I can get the sum of 8? Something like this. 7 and 1. 7 plus 1 is 8. No, don't go with multiplication. Don't go with multiplication. Just go with addition. Yeah, 6 plus 2, 8. 3 plus 5, 8. Yeah, correct. 5 plus 3, 3 plus 5, anything is 4. Okay. 4 plus 4. Okay, that is also there. 2 plus 6. Yeah, 6 plus 2 is done. 4 plus 4, 2 plus 6. Yeah, same things are getting repeated. The order does not matter. It's fine. Now we have 4 numbers. Now out of these 4 numbers, select the number which has only prime. 7 is a prime number. 1 is a prime number. So this one pair I have got full of prime numbers. Is 6 a prime number? Yeah, 7 and 1 is prime number, but 6 is not a prime number. So I will not go with option 2 because 6 is not a prime number. Okay, both the numbers should be prime. Then coming to 3 and 5. 3 is also prime number, 5 is also prime number. So we have another option. Then 4 is a prime number. Is 4 a prime number? No. Very good. So I have come down with the options. So I can only take 1, 2. I can only go with these two options. Now what am I supposed to do next is, let us check which numbers will suit us better. Now I have got 7 plus 1, 8. That is also okay. And then 3 plus 5 is equal to 8. This is also okay. So 2 numbers also will work. Now what is that we are supposed to do is, Go back to your first formula, that is this 27a plus 27b is equal to 216. That also should be 3 and 5 suits well. Okay, we will see that. Okay, 27a plus 27b is equal to 216. Now please apply both option 1 and option 2 in this equation. Let us try. When a is equal to 7, b is equal to 1. 27 into 7 plus 27 into 1 is equal to 216. Please check if you will get the answer. What is 27 into 7? 189 plus 27. 189 plus 27 is 216. This also is coming. No problem. Let us use the same thing with other. When a is equal to 3, when a is equal to 3 and b is equal to 5, 27 into 3 plus 27 into 5. So what is 27 into 3? 216. 81 plus 27 into 5 is 135. Do you still get 216? Yes. Now the numbers out of these two numbers, okay, out of these two numbers, both we are getting the answer of 216. So I can either consider a to be, the numbers to be 81 and 135, or the numbers might be 189 and 27. So what you can do is, thus the required numbers are 27 and 189 or 81 and 135. You will get two answers here because we have found out the possibilities, and when it comes to problems like this, it is okay to get two answers. So there's no problem with that. Do not worry too much. Okay, but when you multiply or divide and add and do anything, you should get back to the same numbers that is given in the question. That is very important. If you don't get that numbers, then any one will be the answer. Okay, so in this problem, we have got two answers. The number may be 27 and 189, that is A and B, or the number may be 81 and 135. Clear? Everybody understood? Any part you want me to explain it again? Anywhere? Good. Okay. Now, okay, this problem is going to take time. We'll do this in the next class. Okay, so this question, the LCM of two numbers is 45 times their HCF. If one of the number is 125 and the sum of HCF and LCM is 1150, find the other number. Now let us see what all is given to us and then we will consider what is to be found out. Okay, so first thing, given is equal to LCM of two numbers is equal to 45 times of HCF. This is given to us. LCM of two numbers is equal to 45 times of 45 into HCF. Can I say that? Yes. Now, if one of the number is 25, so let A and B be the numbers. Therefore, A is equal to 125. They're saying if one of the number is 125. So I'm assuming A and B as the numbers. Out of A and B, two numbers, I know what is A, that is 125. Now we don't know what is B. They have not given us what is B. Clear until here? Understood? Then see from here, and the sum of HCF and LCM is 1150. Sum of, so HCF plus LCM is equal to 1150. Okay, so much information is given to us. Now what are we supposed to find out? Find the other number. Other number is nothing but B. Other number is nothing but B. So we are supposed to find out B. Now to find out B, they have given us two types of equations here. Okay, so let us consider this as equation 1 and this as equation 2. Just for our reference, as of now, whatever information is given to us, using that, I will keep the first one as equation 1, that is LCM is equal to 45 into HCF. And then I'll keep this LCM, HCF plus LCM is equal to 1150. Okay. Now, apart from this, please see the question and understand. How do you know HCF is 25, Spurti? How did you get that? There is no LCM. If you have used equations, well and good. So please wait, let us understand. They have, in this question, they have given you LCM. For an LCM, they have given you an equation, right? In the numbers, they have given only one number. There is no proper record of full LCM or HCF. So what we will do is, for this HCF, let us assume a variable. Okay, let X be the HCF. Okay, let X be the HCF of two numbers. Now we have A and B as two numbers. We know A is 125 and we know B is B. We do not know B. And then coming to the next part, we do not know HCF also. So we will use certain equations here and then we will be calculating that. Okay. Now when I say let X be the HCF of two numbers, I can use the first equation. Okay, Spurti has tried something with equation. Good. We will see if that is correct. Okay, so using this, okay, using this, now I will consider equation 1. In equation 1, in the place of HCF, I am going to put X. So LCM is equal to 45 into X, which is nothing but 45X. Okay, so let us take this as equation 3. Did you all understand until here? 45 into X. In the place of HCF, I've just put X. So that will become 45 into X. Now, moving on further, we also know this formula, right? If you remember, LCM into HCF is equal to product of two numbers. Yes, we also know this formula. LCM into HCF is equal to product of two numbers. Okay. Now, from this equation 3, what is LCM? Sorry for that. From this equation 3, what is LCM? 45x. I can take LCM as 45x and then multiplied with, I told let x be the HCF. So we have assumed x to be the HCF. LCM is 45x, but HCF is x. So LCM is 45x and HCF is x is equal to product of numbers. Now, out of product of numbers, that is A into B, let us see, 45x into x is equal to, out of these two numbers, we know what is A. So what is A? 125. 125 into B. Okay, 125 into B. Now here, I can write this as 45x square, because 45x into x. So I can write that as 45x square. Yes, is equal to the other side it is 125b. Yes, 125b. Now this is another equation that I have got. So I will name this as equation 4. If you are giving me the answers, very good, you have worked it out. Please wait, we will slowly try and understand every step, because there are many others who are trying to understand. Okay. So this is equation 4. Now in the question we have equation 2. Now we used equation 1 and we have solved this. Now there is equation 2. Now what is equation 2? HCF plus LCM is equal to 1150. Yes, HCF plus LCM is equal to 1150. Correct. Okay. Now, so HCF was X plus LCM was 45X is equal to 1150. Now, X plus 45X, this is 1X. Okay. X plus 1X plus 45X is 46x is equal to 1150. Yeah, correct, Gauri. Okay, so where did we stop? 45x is equal to, sorry, 46x is equal to 1150. Then x is equal to, when it is multiplication here and when I take it to the other side, it will become division. So 1150 divided by 46. Can anybody say me what will be the answer for 46? Sorry, x. What will be the answer for x? X is equal to 25. Everybody got 25. Very good. So 25. Now what is my x in the problem? Was that a number or HCF? Yeah, 25. Okay, good. I want everybody to answer. Very good. So X was nothing but HCF. Now we know what is HCF. Okay, now we know what is X. let us go back to equation number 4. Okay, let us go back to equation number 4 and we will apply this x in that. Okay, so substituting x is equal to 25 in equation 4. Okay, so what was equation 4? 45x square is equal to 125b. So 45x square is equal to 125b. This was the equation. So 45 into x square, x is 25 square is equal to 125b. Correct, Padmapriya. Very good. Yeah, you've got B also. Good, Spurti. 45 into 25 square is 625. So 25 into 25 is 625 is equal to 125b. Now 625 into 45. 625 into 45. You will get 28,125 is equal to 125b. Now I am supposed to take 125 to the other side. Okay. Now what will 125 become? Should I divide that, add, multiply? What should I do? 28,125 divide. Very good. So divided by 125 is equal to b. So how much do I get? 225. Many of them have got the answer. Very good. So B is equal to 225. Many of them have solved the problem. They have tried to solve it before. Please keep the pace like this only. Okay. So the final conclusion you're supposed to give is the other number is B is equal to 225. Okay. You just have to understand how you're supposed to do. Any doubts in this problem? Everybody understood? Okay. Now let us go to the next problem. The next problem is a clock makes a beep after every 60 seconds. Okay, so there's a clock. That clock is gonna make a beep noise. You know, a normal noise which happens, you know, every 1 hour or something. So here for every minute it is making a noise. So if you see here, it is 60 seconds. Another clock makes a beep after every 62 seconds. So it's something like an alarm clock. So one clock is making beep after 60 seconds and there is another clock, okay, which is making beep after 62 seconds. So this is the first information. Then they beeped together at 12 o'clock. So both the clocks had beeped at 12 o'clock. Okay, both the clock had beeped at 12 o'clock. Now we are supposed to find out the time when they beep together next. Now at 12 o'clock they had beeped once together. Now next when they are gonna beep together, like at 12. Now firstly say me, should I calculate HCF or LCM here? Which should I use to calculate? LCM. Why LCM? What made you come to the conclusion of LCM? Very good. So there's a word called together or simultaneously. Okay. If you see this word in the question, then you'll have to consider it as LCM. Okay. Now let us start. The LCM of, you're supposed to find the LCM of 60 and 62 seconds. Okay. LCM of 60 second and 62 second is, so let us find the LCM. 60, 62. Both will go from 2. So let us start with 2. 2. 2 3s are 0. 2 3s are 6. 2 1s are 2. Going further, again I can take 2. 2 15s are, and 31 I cannot do anything with 2. So I will keep it as it is. Then now I can go with 3. 3 5s are, 3 1s are. Again 31 is not divisible. So I'll keep it as it is. Then 5 1s are, and lastly 31 1s are, because it is a prime number. Okay. Now to find out the LCM, LCM is equal to 2 into 2 into 3 into 5 into 31. So how much did you get? 1860. You have to write what is the unit also in such problems, because they've clearly told it is 60 seconds and 62 seconds. So 1820 seconds. This will be your LCM. Okay, which means the clock has beeped at 12 o'clock together. Now after 1860 seconds, it is gonna beep together again. That is what it means. I'm repeating it again. Now at 12 o'clock, the clock has beeped together. Okay, at 12 o'clock, the clock has beeped together. Now again, after 1860 minutes, it is gonna beep together again. Did you all understand? Until here, anybody has doubt? Okay. Now let us come to the conclusion. Now we cannot leave them in seconds. We have to convert that into minutes or hours, whichever is applicable. Okay. So what, I'll just add a page here and we will continue. Now we have 1860 seconds. Very good. Okay. Now we have 1860 seconds. Now to convert this into minutes, I am supposed to divide that by 60. Okay. When I do this division, I get 31 minutes. Okay. I get 31 minutes. So therefore, both the clocks beep next time at 12 hours 31 minutes, which means if they have beeped together at 12 o'clock, now at 12:31 they are gonna beep together again. Okay, I'm repeating it. If the clocks have beeped at 12 o'clock together, again they're gonna beep together at 12:31. Understood? Any doubts in the problem? Any part of it? Okay, now we'll go to the next question. Okay. The traffic signal lights at 3 different road crossings change after every 60 second, 90 second and 180 second. Very similar question. Okay. So there's a traffic signal. Let's say it's a very big junction. So you'll have lot of traffic signals, right? When you have a junction like this, all the 4 sides you'll have the traffic lights. So let's say here there are 3 road crossings. Okay, and since there are 3 road crossings, there are three traffic lights, and they keep changing after every 60 seconds, 90 seconds and 108 seconds. Okay, respectively means one after the other they do. If they all change simultaneously at 9:22 hours, means morning, let's say morning 9:22 a.m., they all change simultaneously to red. Okay, at 9:22 a.m. all of them simultaneously change. Now let's say in this road, okay, in this road, one is in red, the other is in green, the opposite is in green, okay, and this side is also red. Okay, now at 9:22 a.m. this will change to red, this will change to green, and this remains this also changes to green. Okay, don't go by the logic how vehicles are going and all that. Okay, for us what is important is traffic signals, traffic signal lights changing its signal simultaneously. At 9:22, suppose if they change like this simultaneously, then if all change simultaneously at 9:22 hours, then at what time will they change again simultaneously? Okay, at 9:22 they are changed together. Now again, at what time will they change together? That is what is the question. Now here, again say me which should I take to calculate, LCM or HCF? Very good. Why LCM? Gauri has given the answer already. Okay, LCM, oh fine, good. Why LCM? Because there is a word which says simultaneously in the question. Correct. So there's a word which says simultaneously in the question. So that is why we are supposed to go with LCM. So let us start. The LCM of 3 different traffic signal lights 60 seconds 90 seconds and 108 seconds are, let us find the LCM. 60, 90, 108. We can start with 2. 2 3s are 2 4s are 8, 2 5s are 10, 2 5s are 10, 2 4s are 8. Again I can go with 2. 2 15s are 45 will not go, there will get a point. 2 2s are 4, 2 7s are 14. Good. Calculate the LCM. Yeah. Then I can go with 3. 3 5s are, 3 1s are, 3 5s are, 3 9s are 27. Again I'll go with 3. 3 3s are 9. 3 5s are 15. 3 1s are 5 and 5 remains. And then 5 1s are. Okay. Now calculating LCM. LCM is equal to 2 into 2 into 3 into 3 into 3 into 5. So what is the LCM that you got? 540. Now again 540 is okay, but then you have to add the unit that is required. So 540 seconds. So which means the signal had changed at 9 hours 22 a.m. Now again after 540 seconds it is gonna change. So now let us find out the proper timing at which the light is gonna change simultaneously. Okay, write down. Thus the light will change simultaneously after every 540 seconds, that is every 9 minutes. Now how did we get 9 minutes? 540 divided by 60. Very good. So 540 divided by 60 will give you 9. You can just write it down here. 540 by 60 is equal to 9. So after 9 minutes again they're gonna change simultaneously, which is nothing but, therefore next simultaneous change will be at 9:22 hours plus 00.09.00. Now find out the timing. The timing will be 9:22 plus 9 is 9:31 hours. Okay, 9:31 hours. Now this last part I will repeat it again. See, how did we get 540 seconds to 9 minutes is 540. If you divide that by 60, you get 9 minutes. So, which is nothing but, previously at what time did the light change? 9:22, correct? So 9:22 plus 9, how much do you get? 9:31. Yes, so this is what we have considered here. At 9:31 a.m. the signal lights are gonna change once again simultaneously. Understood? Any doubts until here? Good.